Hello, hello. Okay. In this video, I want to talk about some sections, have some review, and tell you about. Hello. Okay. Hello. Okay, I have my voice. In this video, I want to. Okay, good. And we'll just test that is it working or not. The live. Excellent. The voice is good. Okay, let's go and start with section 14. I want to recap some most important questions in the exam that related to the section 14. Section 14, ground fault protection. Ground fault protection, we have table 51 for ground fault protection, 1 second or half a second. And so table 51, let me to bring the table, show the table, table 51. We have two tables about the grounding, table 51 and also table 53, table 43. Table 43 and table 51. So this table, minimum size of the bare copper grounding conductor, table 51 is about the minimum size of the bare grounding conductor. For example, in your exam you see 1 second, half a second, and you need to read about the joint, what kind of joint that they tell you in your exam, and then you need to know about the ampacity, amperage of the conductor or circuit breaker of the dwelling unit or apartment. For example, if it is or industries. So if it is 35,000 amp short circuit current, maximum short circuit current. So if they give you that the maximum short current circuit that they calculated for the circuit breakers, for the cables, for the distribution, power distribution in that in the dwelling unit, apartment, or the in the industry, commercial, everywhere, is 35k amp, and they'll give you the type of the joint, and also they'll give you the maximum fault duration, if it is half a second or 1 second. So you will see what is your size, what is your cable size for grounding, for minimum size of bare copper conductor. For example, in this case 35k, it's 250 and 250 kc mil. Okay, so let's go to the section 14. Maximum standard cartridge fuse, not use larger than 600 amp. For cartridge fuse, we can't use, depend on the rule, we can't use larger than 600 amp. Table 25. Table 25 is about the tripping elements. Table 25. How many tripping elements you need to put in your circuit. Table 25. Okay, this table. in your exam, most of the time they ask you about, most of the time, but maybe another things. But always remember, if they ask you how many coils we need in this circuit, for example, for a motor, DC motor, the AC motor, three-phase motor, you need to, if it is just three-phase motor or two-phase or one-phase AC motor, and they ask you about the how many coils they need for overload protection for your device. So for three-phase, 3 trip coils enough. But for DC, there are some different kind. You need to, in your exam, read the question carefully and come here and read this, special this column and this column, and choose how many trip coils you need for, and choose the options in your exam. 2 trip coils, 1 trip coils. For example, in this case, in this column, we have, you start reading this table from the right side. On the right side, first you need to read this column: 3-phase, 2-phase, 1-phase, AC or DC. So in opposite of a lot of tables that they started from the left side, you need to read the first left column, but here first you need to read the right column and choose which system do you use: one-phase AC system or DC or motor or everything, or two-phase AC or three-phase. And also after that you need to read the read your question carefully, which of these words match with your question. And then in this column you can choose how many trip coils you need for the for that circuit or that motor, DC motor. For example, here 2 trip coil. Even if it is DC motor, maybe in some conditions you need to choose 2 trip coils. It means that you need trip coils for both of negative and positive wires. Okay, this is table 25. And table 25, you can find it in section 14-306. So let's go control devices. We know that we have control devices for motors, switches. We use switches for motors, and panel board overcurrent protection, except panel board where more than 90% for overcurrent device. You need to choose overcurrent device like 90%. Solid state devices like diodes, like MOSFETs, like IGBTs, like power electronic devices. So one thing that you can see in your exam, disconnecting means required. This one is rule 14-402. Disconnecting means required. You need disconnecting means for solid state devices. What is solid state devices? Let me ask from ChatGPT. Tell me what is solid state devices. Okay, solid state devices like MOSFET, like any kind of semiconductors that they use in electronic devices, that they use in electronic power electronic devices. Okay, definition. A solid state device is an electronic device that controls electrical current without any moving parts. So, without any moving parts. So, these are electronic devices that they can control your motor, your heater, your everything, electrical devices, semiconductors. So, they use semiconductors inside them. And the semiconductor materials. You know that we have some metals that they are conductors like copper, aluminum, and semiconductors like silicon. Silicon is a kind of most important semiconductor material in the world. And nowadays you use silicon for making a lot of things, power electronic things, solid state devices, and diodes, transistors, SCR, silicon controlled rectifiers, triodes, MOSFETs, IGBTs, solid states. Okay. Nowadays in VFD devices, variable frequency device, VFD devices in MMC rooms, you use they use the MOSFET or IGBT. And also most important devices like rectifiers, like USB devices that they use, or inverters, we use a lot in the electrical jobs and sites, industrial, commercial. They use these devices, solid state devices. So in this book, Canadian Electrical Code Book, section 14-700, start talking about the solid state devices. But one question, I saw it a lot in the exam. It is easy. It's easy. These devices, this kind of devices, SSR devices, solid state devices, VFD devices, PLC systems, all of these use solid state devices, electronic devices. I mean semiconductor devices, and all of them needs, when you use them in your distribution system, in your electrical system, in your electrical board, electrical room, in your VFD panel boards, in your MMC rooms, for the industries, PLCs, everywhere. When you use solid state devices, in this case relay solid state devices, you need to use, by the rule 14-702, you need to use disconnecting means for these devices. Why? Because these devices sometimes they can't stop the current, and it can be danger for the human or for the property or for the next steps devices. So you need to install disconnecting means, disconnecting means, to stop any kind of leakage current. So the key point is leakage current in the solid state devices, because in solid state devices sometimes, for example in MOSFET, you can't stop the current. You can't stop until you give it the reverse current, or in triode, or in IGBT. IGBT is good. It can stop the current, but if it is failed, if it is defected, so it can have leakage current, and it can be danger for human. If you work in a panel that the panel has IGBT solid state devices, for example in a VFD device, so you want to work after a VFD device, for example do a termination, take out the cable or something, because of the leakage current it can be danger. So by the rule you need to use disconnecting means. Why? Because of the leakage current. I saw this in the exam a lot, because this is the rule and it is about the safety, and this book, Canadian Electrical Code Book, is about the safety. So you need disconnecting means for solid state devices. Okay, and section 16, let's go to the section 16, class 1 and class 2 circuits. Class 1 and class 2 circuits. So class 1 and class 2 circuits in section 16. always remember, class 1 circuits start from the rule 16-100, 16-100 class 1, and 16-200 start from section class 2 circuits. So we have this section 16 in the Canadian Electrical Code Book, that this section related to the low voltage or low ampacity, low volt ampere devices or circuits, like controlling, like signaling devices. Okay, so volt amp, about the volt amp of the circuits. So for class 2, volt amp limited to 100 volt amp. So for class 2, limitation of the volt amp is for class 2 is 100. Don't forget it. For the, let me to write it here, maybe. For volt amp, if it is class 2, is 100 volt amp, limitation of the class 2 for volt ampere. And for class 1 is 1000 volt amp. Okay. So always remember, for volt amp class 2 100, for class 1 1000. So class 1 always we can use for higher volt amps. It means that the limitation of the volt amp is on the class 2. It's more on the class 2 for the so the class 2, the power, the volt amp, it means power. So the class, if in your exam, if you see some questions about the class 1, class 2, and they are related to the power of the circuits, for example, for nurse call system, for example, for signaling control of the motors, for PLCs, always remember class 2, the power of class 2 is less than class 1. It means that the ampacity of the class 2 is less. Its class 2 is 100, but class 1 is 1000. So it is about the volt amp of the class 1 and class 2. But I want to... Okay, now it's about the voltage. So voltage of class 1 is limited. Here voltage is different. For the ampacity, for the power, for the volt amp, the class 2 is less. For the voltage, the class 2 is upper. But for the class 1, the power is upper than the class 2, but the voltage is less than the class 2. For the voltage, so class 1, okay? So this one is class 1, this one is class 2. For the ampacity or for the power, for the amp, the class 2 is less than class 1. But for the voltage, just for the voltage, the voltage limited in class 1, limited to 30 volts. For the voltage, the class 1 is limited to 30 volts. But for the class 2, the voltage limited to 150 volts. This one, 150. So for class 1, we limited the voltage. The class 2 voltage is between 0 and 150, but for class 1 the voltage is between 0 and 30, but the ampacity and the power, the volt ampere for the class 1 is more than class 2. This is very important. This is what you need to have in your mind for your logic. This logic of the class 1 and class 2, because in your exam maybe sometimes you need to have a good logic about the exam. Okay, let's go. Class 1 circuit. So class 1 circuit, 30 volts, 1000 volt ampere. And limitation of class 1, I told you already. Limitation of class 1. And okay, limitation of class 2. Limitation of class 2, actually class 2 is limited for the volt amp, the power. So the power is limited. And for the class 2, let me to check here. For the class 2, we have the limitation about the limitation about the volt amp. Where we used class 1 and class 2 circuits, let's go to the next section of the book. Mostly we can say that we use class 1 and class 2 circuits for the control and signaling. But let's go to here. In class 2 circuits, rule 16-200, sub rules A, B, C, D. These are questions. You can answer some questions from these sub rules A, B, C, D. Why? Because sometimes they ask you, for example, sub rule C. They tell you that in a what is the difference between sub rules? These sub rules, for example, sub rule A, for class 2. Don't remember. It's class 2, rule 16-200, and sub rule A. Sub rule A, 1A. So sub rule A. For this kind of class 2 circuits, the voltage limited between 0 to 20 volts. For B, between 20 volts to 30 volts. For C, it's between 30 volts but not exceed 60 volts. For D, over 60 volts but not exceed 150 volts. So they separated in some different cases of the voltages. So in this case, but your volt amp always limited to 100 volt amp in class 2 circuits. In class 2 circuits, always your let me to show you in my Canadian Electrical Code book here, class 2. Okay, so between 0 and 20 volts, between 20 volts and 30 volts, between 30 and 60, and also between 60 and 50, 150. But always the volt amp, the power, is limited to 100. So this is a question. They ask you, in a class 2 circuit, the voltage is 24 volt. For example, in a fire panels, fire alarm systems, we have 24 volts. So the question asks you, in a class 2, the voltage is 24 volts. What is the maximum ampacity that we have in this system? So they ask you, just they give you the voltage, this 24 volts, and they ask you what is the maximum ampacity in this system. They design the system that the voltage is 24 volts, but they want to tell everyone that our system working in class 2. So in the question they told you that the system is class 2. So you can come here and check for different kind of voltages, but the answer is that you need to divide 100 volt amp over 24 volts that the question asks you. So 100 over 24 volts, or maybe they tell you the system is, the voltage is 48, so you need to divide 100 over 48 volts. And in different cases you have different description. So in your exam, you can come here and read about the limitation of every kind of limitations of the voltages in class 2. Okay, so let's come back to the book. Always try to use the book and buy the book. If you don't have the book, buy from the CSA website, and try to touch it, because without the book you can't pass your exam, because at the exam you can find the things in your book. Okay, next section is section 18. Section 18 is about the hazardous location. This is the definition of EPLDA, the first page. EPLDA, EPLDB. In some hazardous locations, some hazardous questions, they ask you about these ones: EPLDC, EPLDGA, GB, GC. And you can find, and they ask you what kind of, for example, they tell you for zone Z11 or Z11 or zone 0, what is the EPL? So you need to check it. This is a kind of question that they can ask you about the EPL, and you need to go and check it in table 18. Let's go to the table 18. Table 18. Table 18. If you, for example, for zone 0, in the column you can see GA. So EPL for the zone 0 is, let me to show you here, table 18. But I prefer to tell you to always, when watching my video, have your book and check in your hard printed book, physical book. Okay, just for here, just one, I just want to show you the table, but it's better to check in your book. Zone 0 GA. See, EPL for zone 0 is table 18. So this is a kind of, for each zone, for example, zone 20, we have DA. You know that the zone 0 and 1 and 2 is about the gas. It's about the gas. But zone 20, 21 and 22, these are about the dust and combustible dust, actually. Dust and fiber. So gas, dust and fiber. But what about this? If we have 0, it's continuously we have this gas. If it is 1, most likely. If it is 2, is not most likely, sometimes, rarely. Also this one, if it is 0, it is continuously we have the dust or combustible dust or fiber. But if it is 1, sometimes. If it is 2, it's rarely. And also about the class and division. Class 1 is for gas, class 1. But zone system is the European standard. So zone is European standard, but class is American standard, North American standard. So class 1 is gas, class 1 is gas. Class 2 is dust, class 2 is dust. Class 3 is fiber. So class 3 is fiber. Class 3 is fiber. Class 2 in American standard, we have they separated dust and fiber. But in European standard, zone 2 like this, 20, 2.1 and 2.2. These are for both of dust and what? Dust and fiber. But for division 1, when we have division 1, it means that continuously we have the gas, because class 1 is gas. Division 1 continuously. Division 2 likely sometimes for the gas. But for the dust, division 1, it means always we have this dust, for example in a industrial room. But the division 2 sometimes, and also for the fiber, division 1 is always, division 2 sometimes. So for EPL, also DA, DB, you can see here, EPL. Okay, so it was about the EPL. Let's go to the section 18 again. Section 18. Section 18, zone 1, zone 1, 0, 1, 1, 1, actually zone 0, 0, 0, 1, 0, 2 is about the gas, and dust, 2, 0, 2, 1, 2, 2 is about the dust and fiber. And let's go to explosive gas atmosphere and studying zone 0. Zone 1. Okay, so section 20, flammable liquid and gasoline. So section 20 is about the liquids, flammable liquids. Section 20, flammable liquids. Hazardous area, commercial repair garage. You have repair garage, like repair the vehicles. And hazardous, definition of hazardous area, when the level up to entire commercial repair hazardous for each floor or above grade, the entire area up to the level 50 millimeters above the floor shall be zoned to location, except that the adjacent area shall not be classified as a hazardous location. So 50 millimeters, 50 millimeters, 50 millimeters above floor, 50 millimeters above floor, 50 millimeters above floor. Don't forget it. The bulk storage plants. In bulk storage plant, maybe you need it in your exam, some questions. But let me to go for section 22. It's for corrosive liquids, locations in which corrosive liquids. Section 22, category 1, moisture, corrosive, like some corrosive liquids. So corrosive liquids are category 2. Moisture and vapor and liquid, these are category 1. So you need to know these. Category 1, category of the locations with liquids. Category 1 for moisture and vapor. Category 2 for corrosive liquids. And also this question. In the rule 22-702, special terminology, continuous positive pressure ventilation. So it is the question they ask you about the ventilation system for maintenance positive pressure for room area, and it is at least 6 times an hour, means okay, for ventilation at least 6 times an hour we need ventilation at least 6 times. They ask you how many times we need ventilation for a system, for this kind of systems for category 1 and category 2. So for these ones we need positive pressure. If we need positive pressure, we need to ventilation. It means that the ventilator blower needs to work 6 times in an hour. Patient care areas, section 24. Section 24 is about the patient care areas. Okay, you need to know about the 600 millimeters above the floor. So receptacles in basic care areas, like not it's basic care areas like saloons, like waiting rooms, like this kind of rooms that they are usually people go to the hospitals. These are the height of the receptacle is 600 millimeters, and 5-15R, 5-20R, 5-20RA, the receptacles that we can use in this basic care areas. Hospital, they need to have hospital grade. But we have also critical area in the hospitals, critical area. The color code of the wires in hospitals, mostly they ask you about this question. Color code: orange, brown, yellow, black, red, black, blue, red, black, blue. We have in residential, commercial, or industry, red, black, blue. Hospital, hospital, orange, brown, yellow. So let me: red, orange, brown, red, black, blue, red, black, blue, orange, brown, yellow. Brown like black, brown like black, red like orange, black like brown, and blue like yellow, So red, black, blue, orange, brown, yellow, orange, brown, yellow, red, black, blue. The color code for three-phase system in residential or in hospitals. Okay, section 26, installation of electrical equipments. Most important section in your exam. We have a lot of questions in this exam. First, it starts with electrical liquid field equipments. Electric liquid field equipment, section 26. Okay, the electric liquid field equipments. These are very important equipments. Okay, indoor. In your exam, first of all, be careful about the indoor or outdoor, because the electric liquid field, you need to check it if it is indoor or outdoor, because the numbers, the digit, the number, the information are different. So if it is indoor, for group of tanks, less in group of tanks, 69 liters for indoor, but 23 for one tank. For one tank, always remember, for one tank 23 liters, for group of tanks 69, for group of tanks 69, but for outdoor 46 for one tank, and for group of tanks 137 for group of tanks. Okay. Let's go. Capacitors. The next part, capacitors, 60 seconds. 60 seconds. Always for the capacitors, remember 60 seconds. Why 60 seconds? What is 60 seconds? Always remember 135 correction factor. Correction factor for most things, for the capacitor, for conductor, for circuit breaker, for everything, is 135. And 30 seconds, 60 seconds. We need 60 seconds for the capacitors. Overcurrent protection. For overcurrent protection for capacitors, 250% for the overcurrent protection of the capacitors. So correction factor for the, you need to calculate the ampacity of the capacitor. They give you the volt amp of the capacitor, so you need to kilovar. And then you need to and they give you the voltage of the capacitor, so you can, if it is three-phase capacitor, you need to divide it by 1.73, and then for three-phase, and 135 is the correction factor for the conductor for the capacitor. If you need to size the conductor for the capacitor, it is 135. So 135% times 1.35. For the circuit breaker, times 2.5 for the circuit breaker. For the conductor, 1.35. For the circuit breaker, 2.5, 2.5. And for disconnecting means, again 1.35 for disconnecting means, 1.35 for the cable conductor. For the cable or conductor, 135. For the disconnecting means, 135. And also for the contactor. For the contactor, if you need to use contactor for the circuit, for the capacitor, if your capacitor is big and you need to use contactor, again the correction factor is 135, but for open type contactor. But for enclosed type contactor, it is 1.5, 1.5. The correction factor for the okay, one question. 5 minutes, it is, this 5 minutes is important. 5 minutes after disconnect the capacitor. Okay, so tap for the capacitor not more than 7.5 meters. So for the cable that we want for this, about the conductor size of the capacitor, so 135. For the capacitor, conductor should be 135. And if we use, when we use cable as a tap conductor, not more than 7.5 meters long. And also here we have the 1/3 rule. A lot of places we have 1/3 rule. 1/3 rules, it is the ampacity of the splitter. So the tap conductor should be 1/3 of the ampacity of the splitter. Okay. And overload 250% or 2.5 or 2.5 for overcurrent protection for capacitor. And disconnecting means, so it cannot be not more than 9 meters far from the capacitor. So disconnecting means shall not be, it should be between 0 and 9 meters. Disconnecting means. And also 5 minutes. This 5 minutes, it's very important. 5 minutes, the necessary time before handling the capacitor. When you disconnect the capacitor from the power, it needs 5 minutes time for discharging, and then you can handle the capacitor. Okay, and so 5 minutes. But look at table 26-2222. 26-222. It's about drainage of stored charge of capacitor. So if the capacitors if the capacitor is for 750 volts or less, 750 volts or less, if the capacitor is working for 750 volts or less, drainage time is 1 minute. This is the question. 1 minute is enough for drainage time. 1 minute. But for more than 750, it's 5 minutes. For capacitor, it's related to the voltage. More than, by the rule, more than 750 volts is 5 minutes. It needs 5 minutes. But if it is less than 750 volts, it needs 1 minute is enough. Okay, and next, let's go for the transformers. Rule 26-240 is about transformers. General transformer, dielectric liquid filled transformer shall mounted so that there is an airspace of 150 millimeters between transformer and adjacent surface combustible material. So, if we want to install a transformer and there is adjacent surface, combustible adjacent surface, at least 150 millimeters between these ones, the separation, the clearance, the air gap between the transformer and combustible material adjacent surface is 150. I have this question, and this is question 150. Don't forget it. 150 for transformers. For transformers, 150 volts for the distance between the transformer, when you want to mount the transformer between the transformer and adjacent wall, combustible adjacent wall is 150 volts. Sorry, 150 millimeters. So, which one? The first, general rules of the transformers. You can find it. But also out the transformers, there are some measurements, dimensions, measurements about the out the transformations and their installations. For example, 3.6 meters above ground, 3 meter from any list, at least shall install at least 3 meters from any combustible surface or material building. For it's about the dielectric liquid filled transformers and transformer mounted on roofs. Also, this one is the question. Transformers mounted on roofs. So for transformer mounted on roofs, we have we need to read the question and come here because we have some temperature, some measurements, nor within 4.5 discharge vents and flammable fans. So and dry core open ventilated type transformers. Also, we have some measurements, some dimensions for installations here for open ventilated type transformers, dry core. And disconnecting means for transformers. Okay, this one is question. We have this question a lot. Rule 26-248. Disconnecting means for transformers. Always we install disconnecting means by the rule in the primary side. primary side of the transformer. Disconnecting means. Okay, and then rule 26-250, overcurrent protection of the power and distribution transformer circuits rated over 750. So for the correction factors, when you want in your exam, you can calculate the ampacity of the transformer by division of the volt amp of the transformer divided by over the voltage of the transformer, and look at to the to question that if it is one phase or single phase or three phase. So after that, if you have the ampacity of the transformer, you need to look at to the voltage of the transformer. Always have a look at to the voltage of the transformer, because in the book we have a limitation about 750. 750 is a limitation, 750 volts. 750 volts. So always in the transformer questions, first of all look at to the voltage of the transformer, if it is 750 volts or less or more than 750. Because for choosing the correction factors in this book you have three different rules. Let me rule 26-250 here, over 750 but rated 750 or less, and this one 750 or less. So you have three very important rules: 26-250, 26-252, 26-254. Always for transformers and their correction factors, you need to come here and have a look at to these rules. These three rules: 26-250, 26-250. These are about the transformers and their correction factors. 26-252. But what is difference? Difference is about the voltage. If it is more than 750, it's rule 250. So rule 250, voltage over 750. And then you can read if it is fuse, if the protection for this transformer is fuse, the correction factor is 150. If the protection is circuit breakers, the correction factor is 300, and so on. You can read depend on your question. But if the question tell you that the voltage, for example 600, the voltage, if the voltage is less than 750, you have two cases. If less than 750, you need to check if it is dry type or other than dry type. You can read it in your question, in your exam. You can read it that if the question is tell you that it is other than dry type or dry type. So in this case you have two different types: dry type, less than 750. So in dry type less than 750, you can read here. You have different kind of correction factors. For example, for circuit breaker, primary current circuit breaker over current protection circuit breaker, the correction factor is 125. For secondary conductor, secondary conductor, the correction factor is 125. For 125 for secondary current, transformer shall not require have an individual overcurrent device. For overcurrent device for secondary, 125. The case dry type, less than 750 volts. But in the case that you have um, over other than dry type, but your voltage is less than 750. So in this case, you have a lot of cases. In case 9 amp or more, the correction is 150. For primary, for overcurrent primary, the correction factor is 150. If the ampacity of the transformer is less than 9 meter, your correction factor should be, for circuit breaker, should be 167. So different kind of, this part is a little bit complicated because you have different kind of cases. Okay. Okay. So it depends on the ampacity, 9 amp or less, and also 2 amp. You can see 2 amps. Okay, and conductor size for transformers, 125 for transformer. Group of transformers, if you have group of transformers, plus 25% of the rated primary current of the largest. Not less than 120 rated primary current transformer. So it is in the case of group of transformers, they are parallel transformers. And overcurrent protection for transformers, auto transformers, rule 26 to 264. It's about the auto transformer. They ask you, maybe they ask you about the ratio, voltage ratio of the transformer, how we calculate it, how we can calculate the ratio of transformers in auto transformers. I'll tell you. And I have a PDF file that I'm talking about the auto transformers in it. I'll tell you about the auto transformer, and its ratio. It's almost same with the general transformers. And also marking of transformers, auto transformers. The point in auto transformers is that the auto transformer, that they are not electrically isolated. So for auto transformer, for general transformer, for ordinary transformer, they are electrically isolated. But for auto transformer, the problem is that this question, fence. Next, 26-300. It's about the fence. So what is the clearance? What is the clearance of equipments? The minimum clearance between the fence and enclosure contained live parts shall be 1.1 meters. So the minimum clearance between the fence and enclosure contains live parts. So if you have a fence and you have, after that you have an enclosure, in the enclosure you have live parts, minimum distance between fence and the enclosure should be 1.1 meter. Live part 1.1 meter. Height of the fence. Height of the fence at least 1.8 meters. So the most important, next important part of the 26. First, it was about liquids, dielectric liquids. Then it was about the transformer, and after transformer, it was about the capacitors. After capacitor, it is about the transformers. After transformers, you can see a lot of distances, clearance, and about spacing, about the dimensions, about the voltages, about fences. In the section 26, it starts 26-300. So live parts 1.1 meter. The height 1.8 meters. The height of the fences should be 1.4 for barbed wires. For barbed wires, the height should be 1.8. Okay. And fence, for the fences, at least we need 3 strands of barbed wire. So at least 3, 1, 2, 3 barbed wires we need at the top of the fences. And if your question was about the fence, if they ask you about the depth, and if they told you in your question that the end or gate or corner, so end, gate or corner of the fence, depth, end, corner, gate, it is 1.1 meter. So minimum depth 1.1 meter for the corners, for the ends, for the gates. But for the intermediate of the fence, depth is 1 meter. So depth for intermediate is 1 meter. So for intermediate 1 meter, for the corners, this corner, for the ends, for the gates is 1.1 meter by the rule 26-308. 26-308. And spacing between the posts shall be 3 meter, maximum 3 meter spacing between the posts. Okay. And the gates, the opening shall be exceed 1 meter. So the opening shall be exceed 1 meter for the gates. And one more question, it's about the 50 millimeters, the fabric, the chain link fabric in the fences, the chain link fabric at least should be 50 millimeters. And have a mesh not greater than 50 millimeters. Also this one have a mesh. If the fence has a lot of holes, they should not greater than 50 millimeters. And use of wood, if you use wood, slats are acceptable. So extend to the within 50 millimeters of ground. And if you had this kind of question that they if you read the question and you can see some key points about the fence and wood, you can come here and there are some numbers here, 2 meters, 40 millimeters apart, and 50 millimeters, and that's it. So fence, wood, here rule 26-314. But what about the top rail? Diameter, pipe size 42.2 millimeters. Or about wood slats. Wood slats shall not less than 19 by 89 millimeters. 19 by 89 millimeters, because it is wood, it's 19. Rule 4, as long rule 4 is about the wood, not less than 19. 19 is the wood. Concrete 50, sand 75. Rule Aslan 1, it's about the concrete, it's 50. At least 50 is about the concrete. About the sand, it's one, it's sound 75 millimeters. For edge is 32 millimeters. Okay, and then okay, after fences, you have a lot of different parts in 26, like electrical equipment valves, cellulose nitride film storage, lightning arresters. So for lightning arresters, minimum connected lightning arrestor, the copper conductor not smaller than 6 American wire gauge. So the conductor for the lightning arresters not less than 6 American wire gauge. And low voltage surge protection devices like arresters, low surge protection devices, resistance devices, panel boards. I just telling you that you need to use this book and read it and just memorize. For example, panel board. You have panel boards or cellulose nitride film storage. If you see in your exam, in your question, you need to know that, oh, I've seen a part about cellulose nitride films in the section 26. That's it. It's enough. In your exam, you don't need to memorize all of these numbers, all of this information, all of these rules about, for example, low voltage surge protective device. But at least you need to know that you have some context in the section 26 about low voltage surge protective devices. So in your exam, because this kind of questions, they are not repeatable a lot of times coming to your exam, so you just need to know that you have a part in 26 about this panel board, about the branch circuits, utility room, solar receptacle, at least one. So this one, it was a question. At least one branch circuit shall be provided solely for receptacle installed utility room. So rule 26-654 subrule C, at least one branch circuit. We need at least one branch circuit for the utility room. But for a branch, how many outlets or receptacles we can install in a branch circuit? We have a part in section 8 that they tell you how many outlets or receptacle you can install in a branch circuit. Look at here, section 8. Section 8. Okay, section 8-304, maximum number of outlets per circuit. So in the section 26, rule 26-654, it tells us that at least we need one circuit, one branch circuit for the utility room in dueling unit. But in section 8-304, maximum number of outlets, we know that for utility room, they tell us for utility room, we need at least one branch circuit. And for a branch circuit, for example, for 15 amp branch circuit with 80% circuit breaker, at least we can install 12 outlets. So for the utility room, not at least, maximum we can install 12 outlets. So minimum number of outlets for a utility room is 1. Maximum is 12 for in a branch circuit. Arc fault devices. Arc fault devices in the section 26. Arc fault protection of branch circuit for dwelling unit. Rule 26-658. Rule 26-658. This rule is about the arc fault protection devices. Arc fault protection devices. And okay. Receptacles. We have a lot of questions about receptacles. 26-700. Rule 26-700. You need to read carefully about the question, and you can find a lot of things about the ground fault circuit interrupter, about arc fault circuit interrupter, AFCI, GFCI, about the different kind of receptacles, about the number and standard of the receptacle, for example 5-15R, 5-20R. We can use for protect the ground fault class 1 receptacles in this part. So you need to read the question and come here and check it. But I'll tell you if I see some reputable questions that they are important for the exam. For example, this one, receptacles. We have a rule. This rule is important because I've seen it about a lot in the questions in the exams. Receptacles for maintenance of the equipment located on the rooftop. So it's about the receptacles and rooftop. So in your question, in your exam, if you see rooftop and receptacle, rule 26-7-10. It's about the rooftop and receptacles. But there are some limitation for rooftops. Maximum distance located within 7.5 meter of the rooftop electrical equipments. So located within 7.5 meter rooftop electrical equipments. For the motors, rule 28. We have another rule in 28-604. For the motors, maximum distance is 9 meter. For the compressors or refrigerant compressors, the maximum distance is 3 meters. So for the motors and for the compressors is 3 meters. For the motor is 9 meter. For the compressors is 3 meters. On the rooftop is 7.5 meter for the rooftop electrical equipments. So, and the height, it should be 750 millimeters, 750 millimeters, not less than 750 millimeters above the finished roof. So the equipments like receptacle shall be installed 750 millimeters above finished roof. For utility room, we need at least one branch circuit, one outlet. Okay. And electrical heating and cooking appliances and heating equipments. Also, we have another section about the heating devices, section 62. Section 62 is about the fixed electrical heating. So, section 26, if we sweep the digits, 26, 62. 26 is about the electrical equipments, and we have about some rules about the heating equipments, and section 62 is about the electrical heating equipments. And let me to talk about next one, pipe organs and submersible pumps in the rules 26-950. 26-950 is about the submersible pumps. submersible pumps. And then we have data processing. Data processing is the next part of the section 26. So let me to summarize. If we need FLA, full load ampacity. If we need full load ampacity for 3-phase, we use table 44. So table 44 is about the 3-phase system and the full load ampacity of full load current of the devices like motors, 3-phase motors. For single-phase motor, table 45. For DC motors, table D2. Table D2 is about the table D2 is about the DC motors. Table D2. Okay, table D2, DC motors. You can find the FLA, the ampacity of the DC motors. Table 44 for the 3-phase motors. Table 45 is about the single-phase motors. Correction factor. For correction factor of the motors, it depends on that if the duty cycle of the motor is continuous or non-continuous. If it is continuous, the correction factor for the conductor sizing is 1.25. So for the conductor, the correction factor is 125. In the case of continuous duty cycle of the motors. So if you have the motor that the working of the motor is continuous, so the correction factor for the cable is 125. Let me here. Okay, so FLA for the FLA 3-phase motor, table 44. First of all, for single phase motor, table 45. For DC motor, table D2. These are for calculations or for FLA or FLC. Full load current of the motor. So after you get the you got the ampacity of the motor, you need correction factor. If you want size the correction factor for size the cable. So for the cable conductor cable or the cable. Okay, for the cable we need correction factor, but it depends on the duty cycle of the motor. If it is continuous, if working continuous, the correction factor is 1.25. If the motor working continuously, the correction factor is 125. But non-continuous, the correction factor is, what is the correction factor? The correction factor is, what is this? The correction factor is T 27. I mean table 27. So if we have non-continuous duty cycle of the motor, we go to the table 27. Okay. Determine conductor size for motors, different requirement of service. So the service is different. What is different? 5-minute rating, 15-minute rating. You can see these in your question. Continuous rating. So it's depend on the rating of the service of the motor. If in case that it's not continuous. If it was continuous, 1.25. But if it not continuous, you can see in your question short time duty, this one, variety duty, and depend on the how many minutes it's work continuously, you can choose 90%, for example. 90%, you can multiply it by your FLA. Okay, so table 25 in case non-continuous. Continuous 1.25, easy. Okay, after that, cable sizing. Now you have the ampacity after correction factor. So let me, this is the first step. Step first. This is the second step. Step 2, correction factor. Step 3. Step 3, what do you need? You need to go to the table 2 or 4 or 1 or 3, 1 to 4 or table 12. So you need or see that if it is copper or conductor. So tables, you go and check tables 1, 2, 3. Most of the time table 2 or 4. Most of the time it's table 2. 1 and let me 1 to 4. Also table 12. These ones. Okay. Step. So conductor sizing for motors in 3 steps. Conductor sizing for motors in 3 steps. Table 44, table 45, table D2, correction factor continuous 1.2, correction factor non-continuous table 27, then step 3, table 1 to 4, or table 12. That's it, finish. I told you because I want to start section 28. Section 28 is about the motors. It's about section 28. It's about the motors. Okay, motor and generators. So S-cord wiring method. Wiring method, rule 28-100. Insulated conductor, if it is continuous load, 1.25. If it not continuous, table 27. And you need to know about the termination temperature of the motor when you go to the tables. It's very important. You can read in your question. So about the termination temperature of the motors, or maybe circuit breaker or overload device for the motor. Insulated conductor, 2 or more group of motors. So section 28-108. If you have group of motors, you need to multiply first largest motor by 125 plus the ampacity or overcurrent of the other motors. So for group of motors. for the group of motors. Group of motors, GM. Group of motors. Largest motor, full load ampacity of the largest motor by 1.25 plus others. Plus others ampacity. Current of all of the motors for cable sizing. And then you go to the tables 1, 2, mostly 2 and 4 and 12. Okay, group of motors, so largest motor multiply 1.25 plus others, full load ampacities or full load currents, just full load current of others. Full load current of other motors. Okay. And okay, rule 28-210. 28-210, instantaneous trip circuit breakers. This kind of circuit breakers, we need to choose the correction factor more than usual. 1300%. 1300% of the full load. 1300% of the full load ampacity of the motor in the case of instantaneous trip circuit breaker. So it's very important. It's a question. It's a question. Why? Because it's strange. 1300% full load current. For example, if a motor has 10 amp, it is the full load current of the motor. So it can be 1300 is 10 times 13, 130 amp. So we go and check which table? Table 13. Table 13. What we can find in table 13? Table 13. So 150. 150. For 150, 130. Sorry, it was 130 because the ampacity of the motor was 10 amp, and by the rule for instantaneous circuit breaker, instantaneous trip circuit breakers, rule 28-10, when you read in your question in your exam that the circuit breaker is instantaneous trip. So be careful, always be careful about this word, instantaneous trip. If you see that the circuit breaker is instantaneous trip, you need to choose this correction factor, 1300 or 15% of the lock rotor. 215 of the lock rotor. Lock rotor current. You know that lock rotor current is 6 times of the full load current. So full load current, lock rotor current equal 6 times full load current. What is lock rotor current? When we lock the rotor of the motor and give it the current. It's 6 times of the full load current. Let me. What is log rotor current of a motor? Log rotor current. You can see in the nameplate of the log rotor currents, and log rotor currents like this. Current, log rotor current, torque, current, pull-up torque. Okay, and then nameplate of the motor. Let me to tell you a little bit about this. Okay, UL listed, standard UL listed, or ULC, Canadian UL or UL. UL is for United States and ULC is for Canada. And CSA. Our book is the book. The Canadian electrical book is from CSA. Lebanon TN USA, the manufacturer, Miller. And AC induction motor. What is induction motor? We have rotor and stator. We don't have sleeps for the induction motor. We squirrel cage motor. High efficiency model. Horsepower 2. So horsepower is 2. Always horsepower is for the output power of the motor. So when we say horsepower, we are talking about the mechanical power of the motor. So the mechanical power that this motor can give us is 2 horsepower. 2 horsepower. So RPM 1725 RPM, the speed of the motor. Service factor 1.15. So service factor, when we want to calculate the overload of the motor, if we want to see how is the overload of the motor, we have 2 choices, 1.15, 1.25. If it is less than 1.15, or they didn't mark the service factor of the motor in your question, you choose it 1.15. But if they give you 1.15 or more than 1.15, you choose 1.25 in your exam and multiply it by the full load ampacity or full load current of your motor. Volts. So the volts of this motor is 208, 230-460. So the line voltage is 460 and the phase voltage is 208. So if you connect the motor in a Y connection, the voltage is 208. But if you connect it in a delta, the voltage is 460. The frequency is 60. In North America, the frequency is 60 Hertz. 3-phase. They give you the ampacity of the motor, so you don't need to check the ampacity by table 44, because they give you, if the voltage was 460, if you connect the motor to 460, the ampacity the ampacity in the full load, if the output power that the motor needs is 2 horsepower, so the ampacity is 2.7 amp with 460 volts. But if the horsepower, it means that the motor is working under the full load, and the voltage is 208. The ampacity, the ampere, is 5.7 amp. The amp is 5.7 amp. But if it is working in full load condition and the voltage that you give to the motor is 230, and it means that it connected in the Y connection, so the amp of the motor is 5.4 amp. And also they give you the ambient temperature, 40 degrees Celsius, 40 degree centigrade or Celsius, ambient temperature, so the motor can work in this. And duty continuous, so they give you the duty cycle of the motor, so you can install this motor for continuous conditions of the work. Code J, it is related to the log rotor induction code letter. And NEMA, it's about the enclosure. And class, it's about the ampacity of the conductors of the winding of the motor. Table 70, table 43, table 40, table 53, I think. Table 53, let me to check it. Table 53. No, not table 53. Table 43, let me to check. Maybe table 43. No. Table 57. No. Table. So what was table 52? No, it's not table 52. Table 52 is about the touch voltage and step voltage. For the tolerant touch voltage and step voltage, they give you the type of the soil and also the fault duration, half a second or 1 second. But we need to find this one. Where is this table? Table 37. Okay, 37. I found it. Table 37. Okay. Table 37. It's about the motor supply conductor. So motor supply conductor insulation minimum temperature rating. So it's about the rating of the conductor, that the conductors they use for the winding of the motor, and the temperature. So the class F, it says that if the motor is enclosed non-ventilated, no ventilated, it's 110. All except totally enclosed non-ventilated, so it is 90 degree. That's it. Okay. And log rotor current, LRC, is the current a motor draws when full voltage is applied to the motor while the rotor is not turning. So we tell it log rotor current while the rotor is not turning So we lock the rotor and we apply the full voltage. But practically we don't do it because in this case we blow out the windings. So they give a percentage of full voltage and then calculate the amount of low lock rotor current. Okay, why is it too so high? When a motor first starts, there is no back EMF. So we don't have EMF to limit current flow. Yeah, EMF always, EMF, it means that the back flux, magnetic flux, limit the current when the motor is working in normal conditions. But at the first start of the motor we don't have EMF, so the ampacity is too much, usually 5 to 8 times of full load current. But in this case, in this book, we times by 6. Always we times in this exam, we times by 6. Example, 20 amps times 6 is 120 lock rotor current of this motor. If the motor full load current is 20, is 120 amp. Why is lock rotor current important? Okay. Why is important? Sizing feeders, selecting motor starter. So we need to choose the starter for motor. We need to size the feeder and conductor of the motor. We need to choose the circuit breaker and fuses for the motor. We need to size calculation of the voltage drop for the motors. We need to check the voltage drop, especially for the big motors. Performance of the motor. For all of these, we need lock rotor current. Okay, and here full load lock rotor 6 times of full load, 1300. Okay, instantaneous trip circuit breakers. So the correction factor is 300% of the full load current or full load ampacity, or if you have the lock rotor current, it's 2.15 times of the lock rotor current for choosing the instantaneous trip circuit breaker. Okay, rated or adjusted for DC motor rated at 50 horsepower or less. So if the DC motor is 50 horsepower or less, to trip at not more than 2.5 times of the full load current. So 2.5 times of the full load current of DC motor. So because in table 20 for the table 29, let me to show you table 29. Table okay, for table 29, rating of setting overcurrent device for the DC direct current motors, the correction factor for time delay fuse or non-time delay fuse always, or circuit breakers, is 150. So in this case, if the circuit breaker is an instantaneous trip circuit breaker, you can choose the circuit breaker in larger size, but not more than 250, because generally you use 150, but you can choose it not more than 250. But if the horsepower of the DC motor is more than 50 horsepower, not more than 200% or 2 times. In this table 29, always memorize. For synchronous motors, low torque, low speed motors, usually 450 RPM or lower, circuit breaker not exceed 2 times or 200 times for synchronous motor, because for synchronous motors you have 175 for time delay fuse, 300 for non-time delay fuse, and 250 for circuit breakers for synchronous motors and also for squirrel cage motors. So for circuit breaker it's 250 250% or 2.5 times of the full load for the, but in this case if it is too small, we choose this correction factor like 2 times, not 2.5 times. So be careful about the exam, because they use these notes to fail you. These rules are very important, because you can use these rules to get your exam, pass your exam, because everyone come here and or not come here, memorize, oh, for circuit breakers this correction factor is 2.5 times of the full load current for the synchronous motors, but you don't come and check the table 29 and you have notes under it. So for synchronous motors, if it is low torque, low speed, the speed is too low, the torque is too low, for example for pumps, compressors, the correction factor is 2 times of full load current, not 2.5, and in this case you fail if you don't check it. And also for this one, for auto transformers or start delta starting, maybe they write it in your question somewhere, in in your question they write it squirrel cage motor, the horsepower is 20, the voltage is like this, the horsepower is like that, the motor is squirrel cage, what is the for example, what is the conductor size, what is the, for example, they tell you what is the circuit breaker size, okay, or what is the non-time delay fuse. And somewhere they wrote start delta, for example they write it like, we have a start delta squirrel cage motor that it is 220 horsepower, the voltage is 600 volts and this and like and that, and they give you a lot of fake information, 3 lines, 4 lines, and this start delta, the correction factor is different for the circuit breakers, 2 times, not 2.5, 2.5 times. About non-time delays, it's different with this one. This one is also screw cage, and also this one can be a screw cage, but the problem is that they write it start delta screw cage motor and it means start delta, and then the correction factor is different for the non-time delay fuse or for the circuit breaker, and you will fail. And also for the non-time delay fuse, see, in this case the ampacity is important. If you calculate and the ampacity is not more than 30, is different by more than 30 for the non-time delay. So these are the places that they trap you and they try to trap you and they try to fail you in your exam. Okay. Let's go to the next part. So instantaneous trip circuits. It was two important rules. You have questions. Instantaneous circuits, instantaneous circuit, star delta, auto transformer, star delta, synchronous motor, low speed, low torque synchronous motor. The question is like this: low speed, low torque synchronous motor working like that, the correction horsepower is like that, the voltage is like that, like this, like that, and then what is the correction factor? What is the cable size? What is the that? What is that? What is the size of the circuit breaker? So you come here, it's 300, but no, it's not 300, it's 200. Okay, be careful. And overload and overheating protection. So let's see what we have here. Overload and overheating protection. So for overload, it's very important, overload protection for the motors and overheat protection for the motors. Overload protection for the motors. Overload protection for the motors. These ones, overload protection. Always we use this one is contactor and this one is overload protection. We feed the overload protection under the contactor, and then this is the input of the contactor. Okay, let me to show you. Okay, L1, L2, and L3. Oh, always remember these. This mark L1, L2, and L3. They can ask you in the question. It is a question. They can make a question with this L1, L2, and L3, or 1, 3, 5, and also T1, T2, T3. So for contactor, always L1, L2, and L3 are the input leads of the contactor. The power for the motor from the top, from some three conductors coming from the top, go to the L1, L2, and L3. And T1, T2, and T3 is output of the contactor, and then go to the overload device. So overload device, we have overload device here. For the overload device, we always can set the overload, adjust it. For example, 21 amp, 20 amp, 18, 17, and also we can reset it. Okay, overload, and after overload device we have motor. So okay, how we okay, this is the control, this is the motor power circuit, control circuit. They use the transformer to get the voltage, or these are the fuse for supply the control circuit, start button, stop button, and starter coil. This is the contactor, and also this is the auxiliary contact of the contactor. This one, auxiliary contact or seal contact for the start. When you push the start, the current flow in this way, stop, and then come here. This one is neutral, this one is hot, come here and go to the coil of the starter. It means coil of the contactor, and the coil of contactor push this contact, and the current, the main power current from these fuses flow and go to the motor, so motor start working. So this is the general type of starter or control circuit and power circuit of a motor. And where is overcurrent? Where is overcurrent device? Generally we install overcurrent device between motor and contactor. A quiz, an example, an exam question in Red Seal, in electrician Red Seal exam. You have 4 options, and they ask you where is the best place for install the overload current for the motor. Before contactor, after motor, before fuse, in the control circuit. Where? The best place is between the contactor and motor. So after contactor, before the motor. So we install overcurrent device here. Overload, sorry, not overcurrent, overload device. And again, we have it here. Overload protection protects a motor from overheating due to the excessive current over a period of time. It is designed to protect the motor winding. So it is overload for motor winding, not for conductors. How it works? When a motor draws more than its rated current for a two-line period of time. If a motor drain a little bit more than full load current, the motor temperature rises, the overload device senses the excessive current, the overload relay trips, and the motor stops before damage or blow up or then defected the insulation of the windings. Thermal overload relay use the bimetal strip, electronic overload relays, overload vs short circuit protection. Okay, so what is the versus overload device versus short circuit protection? Overload protection protects motor from overheating, but short circuit protects against fault current. If we have fault current between the hot conductor or neutral conductor, between the hot conductor or ground, we have fault current. For protect the fault current, motor about the fault current, short circuit protection. But for overload protection, when we have overheating, acts slowly. This one is slowly, working slowly, because it's not too much. We don't have a lot of percentage of the overcurrent. It's a little, for example, 10%, 20%, 30% more than full load current. Act is too much, maybe 20 times, maybe 50 times, maybe 10 times of the full load of the current. Uses overload relays and it acts instantly. Uses overload relays, use fuses or circuit breakers. So fuse or circuit breakers is for short circuit protection for the fault current. If we have fault current, we use fuses or circuit breakers for short circuit protection. But in this case, uses overload relays for what? For overheating of the winding of the motor. It is overload protection. Okay, and that's it. Let's go to overload. So it was overload. So we have two different kind of service factors. In case of service factor, how we can erase these ones? No, I want to rotate the page with the eraser. Okay. Eraser. Okay, that's it. Okay. Now let me for choosing or sizing the overload device, we have service factor. If it is not marked, if in your exam, in your question, they didn't mark it, you can't see any information about the service factor in your exam. It is 1.15 service factor for motor. If you can't see anything about the correction factor in your exam, it means that it's not marked. So the the service factor is 1.15. Also, if they marked it but it's less than 1.15, so less than, if they marked it service factor, for example, in your exam you can see that service factor is 1.1 or 1.08 or 1.12. So in this case you don't have the service factor more than 1.15. In this case they told you that the service factor for the motor is less than 1.15. In this case also we use 1.15 for the service factor. So two cases. If they didn't mark the service factor for the motor, we choose 1.15. And also if they marked it but it is less than 1.15, in this case also we choose 1.15 for service factor. And also let me to come here and see again, if they marked the service factor, in the question you can see that they give you an X as a service factor. For example, they tell you 1.5, 1.3, 1.20, 1.15. So not for yes, 1.15 also, 1.15 also, if it is this, in this case, if it is less than 1.15 less, we choose 1.15. But if they give you 1.15 or more, so I'll put equal here. It means equal. Even if they give you 1.15 or more, 1.15 or more, so they give you the service factor in your exam, in your question, and the service factor is more than 1.15 or equal to 1.15. So for solve this question, you assume the correction factor for service factor 1.25. So we have two different service factor, 1.15, 1.25. If it is less than 125, 115, or they didn't mark it, you choose 1.15. But if the correction service factor is more than 1.15 or equal to 1.15, we use 1.25 for solve the question. But why we need service factor? Service factor, when in your read carefully your question. Always read carefully your. If they ask you for overload, if they ask you for overload of the motor, for overload you need service factor. For overload you need service factor. Look at here, for overcurrent, for fuse, for conductor, for non-time delay fuse, for time delay fuse, for all of these you need full load current of the motor, full load current or full load ampacity of the motor. For all of that ones, for all of that ones, for overcurrent device, non-time delay fuse, time delay fuse, conductors, you need FLC, you need table 27, you need table 29, you need 1.25, you need to go check the rules for the, if it is capacitor. Most of the time, if it is capacitor, for capacitor it's 1.35. If it is transformer, you need to go and check the rules 26-252 and next, because in 3 cases we have different correction factors for transformers. For overcurrent device, for the secondary side of transformer, for primary side of the transformers, and also we have a rule Reza or reserved law. Reserved law tell us that for the transformer in the first side, on the primary side of the transformer, we go to the higher step for the overcurrent device. If the after calculations it was 124 amp, so you go to the higher step and choose 125. If it was 130 amp, go to the higher step and choose 150 amp from the table 13. So always for conductors, for circuit breakers, for fuses, non-time delay fuse, time delay fuse, disconnecting means, for every kind of these protections or devices, you need FLC of that device, full load current. If that device is capacitor, if it is transformer, if it is motor, if the motor is 3-phase, single phase, DC, all of these cases you need FLC. But just for overload, if you need to calculate the overload size of the motor, you need service factor. It's different. For these ones, you need, for these kind of things, you need full load current, and then go to the table 27 or 29, or go look at the rules, to the rules related to the transformers, section 26, section 26 rules related to the capacitors, rules related to the motors, section 28, and go to the tables 1 to 4, go to the table 12 for if the conductor is flexible core. For in all of these cases you need FLC, and after FLC you go to the tables, and then you get the, but for overload it's easy. For overload you don't need to go to any of these kind of tables, or you don't need to go to the rules, you don't need to, just memorize this part. If you just memorize this part, it's enough for overload devices. You just need service factor of the motor, even if the motor is single phase, three phase, or DC motor, you just need service factor. For service factor, you have two different cases. This one, if it is not marked, you choose 1.15. If it is marked and less than 1.15, you choose 1.15. But if they give you the service factor and it is equal to 1.15 or more than 1.15, you choose 1.25. That's it. For service factor, you have just two choices, and you don't need to check the book, you don't need to check the tables, you don't need like that ones, like conductors, like circuit breakers, and then full load current, full load ampacity of the motor, multiply by 1.15 or 1.25, and that's it, finish. So it is about the overload device for the motor. Where we use overload device? After contactor in the control device of the motor in the controls, after circuit breaker, before the motor. Okay, so this is it was the overload device and calculation and size it. And also, one more thing, for the overload device, you don't need to check the table 13. So table 13, T13, we don't need to check it. We don't need to check table 13 after calculation of the overload device for the motors. You don't need to check table 13 because you just write the exact ampere that you get calculated after calculations. You just use that amp, not go to the table 13 and see what is the upper size fuse, standard size fuse, or what is the lower. When we use upper size, when we use upper size of standard in table 13, just when we want to size the circuit breaker for the primary side of the transformer. So for the primary side of the transformer, in the table 13, just for the table 13, just in case that we want to size the overcurrent device for the transformers for the primary side, of the transformer, resolve. So for the first side or primary side of the transformer, if after calculations, for example 27, 26, 28, 24, 23, always we go to the higher level. If it was between 21 and 25, choose 25 circuit breaker. Between 26 and 30, 28 for example, choose 30. But it is for the primary side of the transformer. But for the motors, we go to the lower side. For example, if it was 28, we choose 25. Okay. And okay, so under voltage protection, overheat protection, all of these related to overload, and we talked about the service factor and control. Start with rule 28-500. Rule 28-500 is about the controls. So for control, we have some special digits, numbers. For example, 1/3 horsepower and 125 controlled by the horsepower. So in this case, this is the example. This is a single phase portable motor rated at 1/3 horsepower, less connected by means of the receptacle and attachment plug, rated not. So this is a question: when we can use plug, attachment plug for a motor? You can see here in control 28-500. When the horsepower is related at 1/3 of horsepower or less, you can, and also the ampacity is less than 15 amp and the voltage is less than 125. In this case, you can choose a motor with plug. You can attach a motor to the power with plug and receptacle. A motor controlled by a manually operated general use switch complying with rule 14-5, having one and or two wire DC motor having rated not exceed controlled by a horsepower rated single pole motor. Okay, it's not important. Let me to go to disconnecting means. Disconnecting means for the motors, we need disconnecting means, and tag out, tag in, tag out. Yeah, sometimes, most of the time, we have one question about tag in and tag out for the motors. Why we need tag in and tag out? You know what is the tag in, tag out, because when we want to have a maintenance on a motor, failed motor, we need tag in, tag out for safety. Who has the key for the lock for the motor? The one that installed the tag, the lock. And rule 28-604, we have question here because of the distance 9 meter for the motors. For the motors within site and within 9 meter motor mechanic and 9 meter group of motor and 3 meters for refrigerant. So distance, maximum distance for refrigerant is 3 meters from the disconnecting means. So the location of disconnecting means 3 meters for refrigerant and refrigeration equipments and compressors. But for the motors, motor starter control disconnecting means it is 9 meter. Okay, so very important rule started at 28-700, and it is refrigerant motor compressors. We have a lot of questions for this one, just this rule, just one page, but you need it a lot. Refrigerant motor compressors. So for refrigerant, and most important part is lock rotor, rule 28-708. 28-708, and it is lock rotor. So lock rotor, always, if the fuse trip, you can go to 65% of the lock rotor for a compressor or for a refrigerator. It is a question. You have a lot of question in your exam with this, just with this percentage. 65% or 0.65 times by log rotor. Well, how much is log rotor? 6 times. So for razor, erase this one. Erase. Arrange all of these means these. Okay, 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 okay. Okay, okay. Okay, okay, okay. Okay, 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 okay. Okay, now let me to talk about the lock rotor current for the refrigerant compressor, motor compressors, and 50%. So this is question. We have a refrigerant motor, compressor motor. Refrigerant compressor motor. For this refrigerant, you go and they give you the horsepower, for example 20 horsepower, and they give you the voltage. So you need to go to the table 44. Table 44 if it is three phase. In case it is single phase, go to the table 45, and then from these tables you can get the FLA, full load current of the compressor or refrigerant. So after you have full load current or full load ampacity, if they ask you about the circuit breaker, you need to, for circuit breaker, size of the circuit breaker times full load ampacity or full load current, you need to multiply it or times 3. That's it. Full or sometimes if they give you full load, if in the question they give you the full lock rotor current, RLC. If they give you lock rotor current, you can multiply it by half. Why? Because because lock rotor current is full load ampacity times 6. So, but in this case, most of the time they give the horsepower of the motor, they give you horsepower, and also they give you the voltage of the motor, and then you go to the table 44 or table 45 and you get the FLC, and then from the FLC or FLA, same FLA or FLC, full load ampere or full load current. You can multiply it by 3 and you can get the circuit breaker. But maybe sometimes they tell you that circuit breaker in the question, in your exam, they write it that circuit breaker trip. What does mean? It means that they already use this one, FLA times 3. They use this, but it doesn't work. So in this case, we can multiply FLA multiply by 6. So if we multiply FLA by 6, it is equal to lock rotor current. FLA multiply 6 is lock rotor current. So after lock rotor current, you need to multiply it. Let me to write it. You need to multiply it by 0.65 for the size of circuit breaker. If the circuit breaker, lastly, they multiplied by 3, or I can write it like this: F L A multiply 6, that this is the LRC, block rotor current, multiply by half, 0.5. So in normal conditions we use this one. Normal condition, normal. So for normal conditions, circuit breaker is 3 times of FLA, 3 times FLA, FLA, 3 times of FLA in normal conditions. For compressors, for refrigerant or compressor, 3 times of FLA, or FLA times 6 times half. FLA times 6, it means log rotor current of the refrigerant. So log rotor current times half, it means that circuit breaker size in normal conditions. So this one is log rotor. Log rotor. Log rotor times half. It gives you the circuit breaker in normal condition. But in your question, always be careful about this word. Be careful about this word. When you see refrigerant, compressor, this word is very important. Trip. If it doesn't work, it's not in normal conditions. So in this case, you need to multiply it by 65%. So I summarize like this: trip in your exam. If you see this word, trip, it means that the circuit breaker can't work in normal condition. It's trip after starting. So trip 65% or 0.65. This is the summarize of this part. No one tell you like this. Trip 65. Trip 65. In your exam, if you saw trip 65, refrigerant. For which kind of refrigerant? For refrigerator, for compressor, for the motors, for for refrigerator. If you see trip 65%. Okay, that's it. Okay, now we can go and start with which part? Okay, refrigerant motor, I've already told about it. Rule 28-710. We have two different parts about overload relay. 140 times overcurrent times full load current, or in case of fuse 1.25. So in case of overload relay 1.5 for the refrigerants, for the refrigerants, if overload relay in this case, if in your exam you see overload relay, for overload relay correction factor is 1.4 times full load current. But if overload is not, if the protection is not overload, it is fuse. In case of fuses, the correction factor is 1.25. Which rule? Rule 28-710. Okay, this one, overload relay, and it's about refrigerant and compressors. For refrigerant and compressors, we have these two percentage for the overload relays and fuses, 1.4, 1.25. Disconnecting means, if they just tell you about the size of disconnecting means, the size of disconnecting means for the refrigerant and compressors is 1.15, 115% for the full load current of the motor or refrigerant of the compressor, not the motor, refrigerant, compressor of the refrigerant. So 1.15 multiply 1.15, and then you need to go to upper side. For the disconnecting means, always remember, for the disconnecting means, you go to the upper side. For the disconnecting means, you go to the upper side. Don't forget it. For the disconnecting means, you go to the upper side. Okay. For disconnecting means, you go to the upper side. Like cables. When you multiply cable, for when you want to size the cable 1.25, and you want to go to the table 2, for example table 2 or table 12, you go to the upper size, because the cable wants to fit the device, motor, transformer, everything. So it needs to carry a lot of enough current. Also for disconnecting means, you need to go and check the upper side. Also for the transformer, primary side of the transformer, for the circuit breaker, we go to check the upper side. But for the circuit breakers, for motors, we go for fuses, for circuit breakers, non-time delay fuse, time delay fuse, we go and get lower size of the circuit breaker or fuse or everything, because it's protection. We want to protect that device. Okay, that's it. It was a quick review of section 28. Section 28. It was a quick review for section 28 of Canadian Electrical Code Book. Canadian Electrical Code Book Part 1, CSA C22.124. CSA, the book. The book is CSA C22.124. So it is about this book. So we'll start section 30. It's about the lighting equipment. Lighting equipments. So what is important? What are the okay? So rule 30-104. 30-104 is about the protection circuit breakers, fuses for the lighting systems. Section 30 is about the lighting. So section 30 is about the lighting, and rule 30-104 is about the protection for these lighting circuits. And protection, for the protection, 15 amp where the input voltage is greater than 347 volt. So 347 volts or more, 15 amp, but in the case of other than dwelling unit. So for dwelling unit we use 15 amp for the circuit breaker for the lightings, for lighting, for the circuit breaker for the lightings, protection for the lightings in dwelling units, 15 amp. That's it in your question. If it was dwelling unit, 15 amp circuit breaker, finish the rule. But in the case of other than dwelling unit, I mean apartments, commercial, industrial, 15 amp where the input voltage is great. If the voltage is greater than 347, so the amp of the circuit breaker is 15. If the voltage is less or equal to 374, 347 volts, if the circuit breaker we need, we can choose 20 amp. So 15 amp less than more than 347. Why? Less amp, higher voltage, because power is voltage times amp. The voltage, when the voltage go upper, the amp can come down. So for 347 or more, for more than 347, in this book, every time, every number, when they talk about it, it's not that number. That number is that number or less. But for example, 347 or less. But if you go up, it's not consist of that number, involve that number. So 15 amp for 347 upper, but 20 amp for 347 and less. And also, so we have two cases after dwelling unit. For dwelling unit we have 50 amp. Other than dwelling unit we have two cases, 15 amp for upper than 347. For 347 and less we have 20 amps. But in the case of some special lightings like HID, high intensity discharge luminaires, or in case of lamp holders incandescent marble base type, in these cases halogen luminaires, in these cases we can choose 40 amp circuit breaker. But in case of HID luminaires, high intensity luminaires, it should not exceed than 120 volts. The voltage should not exceed 120 volts. Tungsten halogen luminaires, double-ended lamp holders, not exceed 240. So in this case, if it's not exceed 240, or for high intensity discharge HID, all of these are questions. You can see in this question, example questions. So be careful about this part. This part is very important. Every part of this, every of these numbers, every of these voltages, every of these definitions can come in your exam. So in the case of 40 amp circuit breaker, for special like in incandescent, for high intensity discharge HID, like
tungsten, halogen luminaires. In these cases, or luminaires provided with integral over current devices. All of this, in these cases, A, B, C, D, the circuit breaker can be 40 amp. But there is a exemption, luminaire provided rated not more than, all of these they tell you not exceed 120 for the HID. They ask you not exceed 120. In the case of tungsten halogen luminaires, they ask you not more than exceed 24 volts, 240 volts. And in the case of luminaires provided with integral overcurrent device rated not more than 15 amp or voltage not exceed 120. So be careful about 120 volts, 15 volts, 120 volts, 240 volts. In case of circuit breaker is 40 amp. So if it is voltage, it is more than, in these cases, you need to go and choose the 15 amp where the input voltage is greater than 347 volts. Okay. And another question, it is about the supports for the luminaires. Rule 3, installation of lighting equipments, it starts from rule 30-300. Rule 3-300, and we have some supports, special rigid PVC boxes and supports, and we have some kilograms here. How much can be heavy the luminaires? For example, 13 kilograms does not exceed. Where the weight of the luminaire does not exceed 13 kilograms, the luminaire shall be permitted to be supported by wall outlet box attached directly to the building structure. So it needs to attach to the building structure. It needs to outlet box, wall outlet box. So wall outlet box that attached to the building structure, 13 kilogram. But for the luminaire shall permitted to support ceiling outlet box. For the ceiling outlet box, it can be 23 kilogram. 23 kilogram ceiling outlet box, 13 kilogram wall outlet box, and also 2.7 kilogram where luminaire weight more than 7 point exceed 700 millimeters in any dimension. The box need to be more than 4 by 4. Okay, and then ballasts. One more important part, rule 3-310, luminaires as a raceway. Minimum voltage is 600 volts, not less than 600 volts. Ballast located luminaires, and the voltage rating, it means the conductor supply the luminaires. It means the insulation voltage of the conductors not less than 600 volts. This is the question. This one is important question. So if we have the ballast. Well, what is the ballast? Let me to show you. What is ballast in luminaires? Okay, ballast, electronic ballast. These are, and also this one is question. Okay, let me, okay, good time. One question, how many wires we need for electronic ballast? Here or in your exam? For example, if the ballast support 2 lamps, and also in this case 2 lamps. So how many, the question in your exam, the question is how many wires the ballast needs for 2 lamps. It is question. The answer is 2, 2, 4, and 2 for the supply, and again 2. Correct? It's not. This one is not correct. I think the AI created it is not good, but I know the answer is 8, like this. Yes, this circuit is not correct, but this circuit is correct. 8 wires for the ballast, electronic ballast. For 2 lamps, we need 8 wires. But if it was just one a ballast for just one lamp, we need 6 wires, 4 wires for the lamp and 2 wires for the supply of the ballast. But in this case, we just need 8, because two yellow wires go to the both of the lamps, and reds and blues go to the each of the lamps, and this one, black and white, is for the ballast, electronic ballast, like this one. Electronic ballast, red, and we have yellow also, yellow and black and white, electronic ballast. So definition: a ballast is a device using a fluorescent HID. HID. What was HID? HID was high intensity discharge. High intensity discharge. Fluorescent. High intensity discharge. And some other discharge lighting systems. For these ones, we need ballast. Provide the high voltage needed to start the lamp. Because for this lamp, this kind of lamps, we need arc. And we need high voltage to make arc in the lamp. So we need ballast. Limit the current after the lamp starts operating. So first of all, they need they provide the ballast, provide the high voltage, and then they limit the current after starting the light. Without the ballast, the lamp would draw excessive current and could be damaged. Simple explanation: think of the ballast current regulator for the fluorescent lamp. Start the lamp, control the lamp current, protect the lamp from overheating. So one of the duties is limit the current and prevent from overheating. Type of ballast: magnetic ballast. In the past, we had magnetic ballast, choke. It was magnetic. It has a core, a steel core and copper winding. Use coil and magnetic core, like motors, heavier and less efficient, a lot of noise and humming. Yeah. What electronic ballast? Use solid state. Okay, solid state. I already talked about the solid state electronic components. They use semiconductors for solid state electronic, power electronics, industrial electronics, lighter and more, like IGBTs, like MOSFETs, like the transistors, like diodes. Common, so solid state. Common in modern luminaires. Okay, power source, ballast, and fluorescent lamp. Okay, that's it. Okay, we are here. So ballast. So the conductor that we use for the ballast, by the rule, is question. At least 600 volts. The insulation of the conductor should be at least 600 volts. Have an insulation temperature not less than 90 degrees. So these two important rule 3310.
310. Where is 30? 310. Where is the 3? Okay, this one. Okay, here, luminar the raceway. So these are question in your exam. What is not the voltage should be not less than 600 volt, and the ampacity not less than the ampacity of the insulation. The voltage of the insulation, the conductors that we use for the ballasts, for the luminars, for what kind of luminars, for the fluorescence, for the HID luminar fluorescence, for the luminars that they need high voltages and limited current. So we need ballast, we have magnetic coil ballast and also electronic ballast. They use solid states electronic, power electronics, semiconductors, and rating of the conductor should be not less than 90 degrees centigrade, and also not less than 600 volts. Okay, let's go to the next question in this section, section 30. Expose wiring for permanent outdoor lighting, extra low voltage lighting system. Expose wiring for permanent outdoor lighting. It's about the lighting. Exposed wiring for permanent outdoor lighting, extra low voltage lighting system like LEDs, extra low voltage lighting systems. It means, of course, they're talking about LEDs. And then section 32 is about the fire alarm system, smoke alarms. Okay, in this case, about section 32. In the section 32, we have two very important class A, class B. Class A and class B is about the fire alarm system. Class A, in the class A and class B for fire alarm, always remember this is the most important. You need to know about the class A and class B in the fire alarm systems, and what are the EOL, end of line resistors. And also you need to know about the addressable. What is the addressable? What is the conventional fire alarm system? So as an electrician, you need to know about the class A and class B, how we put EOL, end of line resistor, at the end of class B circuits for the fire alarm, how we make a loop for class A. We start from the control panel, go to the detector, initiating devices, pull station, relays, relay modules, to the monitoring modules, to the isolation modules, to the beam detectors, to the heat detectors, to the smoke detectors. Make a IDNet, make a loop, go start from the panel to the class A. Start from the panel, 2 wires, go to the all of the initiating devices, detectors, everything, and then come back to the panel. So it is class A. What is class A? Class A, start from panel, go make a loop and come back to the panel. It's class A. But if we have panel, 2 wires, go to the device, initiating devices, go to the detectors, go to the pull station, to the every kind of non-addressable conventional devices, or even addressable devices, go to them, and then at the end, after last device, initiating device, if we have EOL, end of line device, it is a resistor. In this case, we call it class B. Class B, we have EOL, end of line resistor. But in class A, we don't have. We come back to the panel. But in class B, we can have
initiating devices, pull station, everything. And what is the addressable? What is the conventional? Conventional, we have definition of zones. Zone 1, 2, 3, 4, 5. For every part of the building, we define a zone. We try to make a zone like every closed parts of the building. We don't after the doors, after the floors. So we have zones. In case of fire, in panel, if security go and check the panel, security can see which zone has the fire, but no details about the detectors, no details about the pull stations, no any detail. It's a conventional diagram of fire alarm system. So as an electrician in your exam, you need to know what is conventional fire alarm system. Conventional fire alarm system, you don't have any details about the initiating devices like heat detectors, smoke detector, pull stations, every kind of the insulation relays, insulation modules, relay modules, monitoring modules. You don't have any information about them in case of fire. About the flow switches in the sprinkler system or what. But in addressable system, each of devices has its own address with deep switch in the electronic board of the device. For example, smoke detector, heat detector, you can see a deep switch. You can set the number of the device, something between 1 to 20 to 55, because it's 8 bits, 8 deep switches. So you have 2 power 8, 255 cases, 255. In an IDNet, in a loop, in a class A IDNet fire alarm system, you can have up to 255. In case of different manufacturer, different a little bit, but you can have 255 devices that each of them has their own address in the loop, in the system. So in case of fire, when the security of a building, for example, a lot of rooms, a lot of apartments, a lot of suites, a lot of apartments, in the case of fire, the security of the building can go and check which room, which detector has the alarm. So this is the definition of the addressable system versus conventional system. Class A versus Class B. And also you need the definition of the initiating devices, automatic initiate. We have 2 different initiating devices. Automatic, manually, like smoke detector, heat detector, beam detector, monitoring module. These are automatic initiating devices. How is automatic? Because no one wants to be at this job site. No one wants to be at and do something. The device detect the fire, smoke, heat, and active the alarm. But pull stations are the manual initiators. Pull station, someone need to know about the fire and go and activate the pull station. So that's it. So class A and B, I already talked about it. Conventional and addressable, I already talked about it. Automatic and manual initiating devices. And then, okay, we have a question here in rule 32-100. 32-100. This is question. Why? Because sometimes they ask you what is the minimum insulation temperature for fire alarm conductors. Minimum temperature for in this question is very important question in your exam, because it is about the safety of the fire alarm, safety of the fire alarm system, and fire alarm system is about the safety of the system, property, people. So this book Canadian Electrical Code book is about the safety. So you can see this question a lot. 300 volts. 300 volts is the minimum temperature of the insulation of the conductors for a fire alarm system. Don't forget it. 300 volts minimum voltage for the insulation of the. So what was the 600 volts? I already talked about it. 600 volts. We had 600 volts. Yes, 600 volts. It was the conductor of the luminaires that they have ballast. For the luminaires that they have ballast, 600 volts. Oh, we have here 600 volts. 600 volts for the ballast. And also 90 degree for the temperature of insulation for the ballasts. When we have ballast, it's 90. So memorize these two numbers, 90 degrees and 600 volts. And also let me to go where I was talking about 100. Okay, here this 300 volts. Memorize this one. 300 volts, the minimum voltage of insulation for conductors, insulation rating for the fire alarm system. 300 volts. For the luminaires that they have ballast, 600 volts. Also this one, more than 7 strands. So stranded insulated conductor with more than, we need to use these ones. When we want to connect them, we need to bunch, tinned, or terminated in compression connectors. So this is also, this one is question. This one is correct. When we have stranded conductors for fire alarm system, that the strands of the conductor is more than 7, so we need to bunch, tinned, or compression connectors for splice them. And also this one, also this sub rule 4, it's very important in your question. I've seen a lot of questions that they ask you about how they ask like this: what is the minimum size of the conductor for one conductor in a raceway for a fire alarm system? That conductor laid in that raceway. So minimum size 19. See, laid. If you see laid, this, be sensitive about this word, laid. Laid in a raceway. If it is laid in a raceway, minimum size is 19. If it is pulled in a raceway, minimum size is 16. So if it is pulled, 16. Because when you pull, you need a stronger wire because you pull it. But if it is laid in a raceway, it's 19 is enough. So minimum size 19 for laid, minimum size 16 for pulled, for fire alarm conductors. But let me go further about the 19. In there I must say 2 or more. Sometimes they ask you, we have 2 or more insulated conductors for fire alarm system. What is the minimum size of the conductor? You need to choose 19 in your options. Also, maybe they ask you 4 or more insulated conductor for a fire alarm system. For a fire alarm system, we have, and also another thing. Always in your exam, maybe they ask you about the raceways and conduits, about fire alarm system. If they talk about the fire alarm system, raceways and conduits, always remember red, color red. Color red is very important. In your options, when you want to choose an option, always be careful about the red color for the raceways and for the conduits, because for the fire alarm system, and also not just for raceway, about the circuit breaker, about the devices, electrical, about the boxes, if you see in your options red, be sensitive about the red, about fire alarm system, because for fire alarm system, conduits, raceway, circuit breakers, boxes need to be red. So for the four or more insulated conductor in a raceway, minimum size 22 American wire gauge. Okay. Okay, now metal raceway. Aslan rule 1 again. Rule 32-102 about wiring method. Sub-rule D. Non-metallic tubing where embedded 50 millimeters concrete or masonry or concrete 50 millimeters. Aslan rule 1. 50 millimeters is about me because I I introduced this rule to the world about CEC book. This book everywhere, every question in your exam when you see it's not depend on the fire alarm, it's not depend on the section 12, everywhere. If they talk about the concrete, Aslan rule 1, 50 millimeters, or if you see 50 millimeters, be sensitive about the concrete. Okay, smoke alarm, carbon monoxide, fire pump. Okay, fire pump. Also, this one is important in your exam. Okay, 125 of the sum. Rule 32-300. 125 of sum of full load currents of the fire pumps, juki pumps, and fire pump auxiliary loads where two or more motors are provided with the fire pump and be protected against the... So it's about the conductor, how we size the conductors for the fire pumps. So it's not like group of motors in section 28. In section 28, when we had group of motors in section 28, group of motors, when we have group of motors, we want to size the main conductors that we have a splitter, we have a bus bar, main bus bar. We have some motors, let me to show here, it's better. I already talked about the FLA, circuit breaker, in refrigerant compressors, so you can check it in my video before of this. I talked about these ones, all of these 6 times full lock rotor motor and lock rotor current 6 times, and 50% of the lock rotor for the normal conditions for motors. But if it is not, if it is trip, this is the Aslan rule. Trip 65%. Okay. Okay. We have board. Now, for the fire pumps in the section 28. Section 28. Okay. In section 28, they tell us that if we have a bus bar or a splitter and we have some motors, group of motors here, M1, M2, M3, M4, we have some conductors, we have circuit breakers for these conductors, we have control boxes, we have control box here, we have circuit breaker, control box, inside of a control box, inside of this control box we have contactor, we have overload device, So each of these motors, M1, M2, M3, M4, they have their own control devices, and when in question maybe they ask you about this conductor, if you want to size this conductor, you need to have the full load ampacity or full load current of this motor, this M4 motor. You need to go and check the table 44, full load current, table 44. How we get it? Table 44, table 44 or 45 for single phase. For single phase motor, if these motors are single phase, table 45 is this motor. If the motor is three phase, table 44. If the motor is DC motor, table D2. So with these tables you can get the FLA of the motor. So after get the FLA, you need to size this conductor. If you want to size this conductor, you need to go. First of all, you need the correction factor. The correction factor, the correction factor, if it is continuous working, this motor working as a continuous, the FLA, the correction factor for continuous case, in the case of continuous, is 125. So 125 correction factor in case of continuous. But if it's not continuous, you need to check table, which table? Table 27. Table 27. So we have a motor. We go to the table 44, table 45, table D2 in case of the motor, which motor the question asks you, and then get the FLC or FLA, and then in case of continuous service of the motor, if it is working as a continuous, you can see it, you can read it in your question. If it is continuous, so the correction factor is 125. If the question tell you talking about the 15 minutes, 5 minutes, 30 minutes, if it is tell you some things like this, you need to be careful, sensitive about the table 27. Table 27. 27. Let's go to the table 27. Okay. If your exam, you see 5-minute rating. You see that they wrote periodic duty, short time, intermittent duty, variety. These, be careful about these words, about the cable sizing. If they ask you about the size of the cable in a motor, so you need, and also you see 30 minutes, 50 minutes, 5 minutes. In your exam, come to the table 27 for what? For conductor sizing of a motor in different service. So this is correct. So it was table 27 in case. And then after correction factor, you need, after this, you need to go and check table what? Table 2 or table 4 or table 12. Table 2 or table 12. Most of the time table 2 and table 12, but in case of aluminum you need to go and check table 4. Okay, after that you go and size this conductor. But in the control device we have contactor, we have overload. For size this overload, we need this. The service factor of the motor. For size this overcurrent device, the contactor, we need go check the rule for the motor. We had two different kind of contactor for capacitor actually. If we need to size the circuit breaker, we need to go and check the table 29. Okay, so after all, in this case, we are talking about the group of motors. So for group of motors, we have a conductor here. We want to size this conductor. We want to know about this conductor. We want to size this conductor that feed this splitter, and this splitter feeds with tap conductors. These are tap conductors for some motors. For some motors, you already can size the cable, you already can size the circuit breaker, the contactor, you can size the overload device, everything. But for sizing this conductor X, okay, now I'm here, section 28. Section 28. We need to write it here. For X conductor. If we were in section 28, it means that for motors or refrigerants or compressors, in this case, we choose the largest motor, full load current. Largest motor, full load current. In section 28, if we want to size this X, where is the X? X is this conductor that feed the splitter. The splitter feed a lot of motors. So in section 28, we say that that largest motor times 125 plus others. Okay, so in section 28, if we have group of motors, we multiply the largest motor FLC by 125, and then go to the other motors and just add them to this amount, and go to this table 2, table 4 or table 12 and size the cable. But in section 32, in the section 32, it's about safety. Section 32 is about the fire alarm system, and the rule 32-300 is about the fire pumps. Fire pump. Because of that, because it's about the safety, and we will choose higher range of the conductor, because we want, when in case of fire, we want to these fire pumps non-stop working without any problem, work till end of the water, end of the fire. So in this case, we just add, or we do like this, 1.25 times all of motors, times all of motors FLA or FLC. Okay, so in case of fire pump, we multiply 125 times all of the motors FLC. First we add all of these and then multiply by 125, but here we just multiply 125 for the largest one and then add others. It's different between difference between the table, the section 28 and section 32 for the group of motors. Section 28 for group of motors, for conductor sizing, we just rate of trip, overload, group of motors, single branch circuit, group of motors, overcome protection. Okay, rule 28-108, two or more motor, group of motors, the full load current 125 motor having the largest plus plus the full load current rating of all other motors. So which rule? Here rule 28-108. 108. This one in section 28, but in section 20 in section 32, when we want to size the conductor for the group of the fire pumps, it's section 300. Section 300. It's 125 times all of the motors. But here we just multiply 125 by largest size motor, not all of the motors. Okay, this is the difference. And for fire pumps, it's very important. And class B, we have end of line resistor. Class A, we come back, go to the fire alarm panel, and for conduit PVC fire pumps, we can use, if we use the concrete around it, and that's it. That's it. Okay, for section 32, I have a file. I have another video actually for the section 32. You can watch it. And we have more explanation about section 32. Okay, and also you can go and check the this website, Tesla exam. I try to write some comments on the questions in this website, so you can use that comments. You can use and also you can use free questions in this website, teslaexam.com. You can use some free question about CEC and check yourself that how you about this exam, if you are ready for the exam or not. But I already try to put some comments and as an admin try to make better questions for this website. Okay, and section 34 is about the signs and outlet. Section 34, let me to find most important questions. Okay, this one is question for rule 34-400. Rule 34-100, high voltage wiring method. Sub-rule 5, where high voltage cable are installed non-metallic conduit, the separation of conduit from the conductor material. So it is about the combustible material for the signs, for the neon supplies or the signs, combustible material. So if the device, the lighting, the sign, is the frequency of operation frequency is 100 hertz or less, at least it needs 38 millimeters of distance with combustible material. So 38 millimeters distance between the device and combustible material. But if it's not combustible material, if it is more than 100, so you need 44 millimeters separation between combustible material and the high voltage cables of this system of the installed in a non-metallic conduit. If the cables for a sign installed in a conduit, in a non-metallic conduit, that the frequency is more than less than 100 or less, the minimum separation is 38 millimeters. But if the frequency is more than 100, the minimum separation is 44 millimeters. And also run inside GTO sleeves to a point at least 50 millimeters inside the raceway. So the point inside the raceway, inside GTA sleeves. Also you can find about the GTA sleeve, and also this one is question, GTA sleeve for the signs. G2 sleeves enclosed high voltage cables in show window and similar locations. So for show window, high voltage cables, you know, for the signs, for the show windows, neons, actually neon supplies. For the neon supply we have high voltages, and for these ones we need to we have some rules, and one of them is that be enclosed in a GTO sleeves. So this one, be enclosed, rule 34-402, be enclosed in GTO sleeves. Okay, and next section, section 36, it's about high voltage installations. High voltage installations. So high voltage installations, section 36. When we say high voltage, when the scope of the section 36-0, scope of the first sub rule, the section apply installation exceed 750 volts. When we say more than 750 volts, depend on the rule, it's high voltage. So we have some rules about the warning notice. We need warning notice, notices for the high voltages, and installation interval not exceed 15 meters. So for the warning notices, installation in intervals not exceed 50 meter. For the high voltages, adjacent the logs of the formed 15 meters. So memorize this one, 15 meter. 15 meters is very important for this section. 15 meters for the signs, for the warning notices. And wiring method for high voltages, TC tri-cables. TC tri-cable for high voltages, we need to use TC tri-cables, and 16 MSG, we have 16 MSG for the barriers of the sheet metal not less than 16 MSG or 1.34 thickness for the barriers between the conductors, high voltages conductors. Rule 36-100. And also radi bends are very important in high voltages, and this section, radi bend, you can find in table 15. So table 15, don't forget it. Table 15 is about the ready bends. Ready bends, table 15, ready bends, table 15. So try go and check table 15. It's about ready bends, and in your question, in your exam, of course, you can see some questions about table 15. Table 15 is about the ready bends for high voltages. Table 15. Table 15, this table. In your exam, you can have some questions about this table. Value minimum times, how many times you need to multiply by the size of the diameter of the cable up to include 25 if the size of diameter of the cable is for this column is including 25 up to it means less than 25 and 25 or over 25 diameter. So 25 diameter till 50 millimeters diameters over 50 millimeters. So the bending ready for high voltage cable, table 15. So try to memorize it. Remember, table 15 for high voltage minimum ready, bending ready for portable power cable. If we have portable power cables in high voltages, so for high voltages, if we have portable power cables, and we have two different cases. If portable power cables is 5 kilovolt or less, the minimum ready bend is 6 times. But if the portable power cable over 5 kilovolt, the minimum ready bend is 8 times. So 6 times for 5 kilo and less. For 5 kilo, for more than 5, over 5 kilo is 8 times. Always in this book, when we have a limitation, for example 5, we have a designation number 5 kilowatt. When the 5 kilowatt volt is with the less ones, so the less and the exact number group in a one case, and the upper is another one. So here also for upper, for less 5 kilo and less is 6 times, for over 5 kilo 8 times. So wire shielded 7 times, non-shielded 7 times for different diameters of the conduits and the cables, for the cables actually. Smooth aluminum sheeted. So this one, corrugate aluminum sheeted or smooth aluminum sheeted. You have these questions in your exam. You have these ones. So if you see this corrugated aluminum sheeted or some high voltage, and also be careful about the high voltage and bending ready, come to the table 15. Table 15. And also one more thing. Sometimes these can help you in your exam. See rule 34-400 or 36-102. These numbers can, these rules in the tables can help you to find better, to find your answer. Because sometimes you go to the table parts of the book, find the table. For example, you just look at and searching the tables and you find the right table. But you can't find the right answer in the table, so you need to go and check this rule 36-102. Okay, or also 34. So table 34, section 34, it was about the signs and signs, especially high voltage signs, known supplies. These are the high voltage signs, and the rule 34-400. It's about the wiring method, and in this case, you can find about the table 15, about the minimum bending. Okay, And then section 36, table 15, radio bands, table 15, shielding of the thermoset insulated conductors. So it's about the shielding of the thermoset conductors and what the voltages. It depends on the voltages, and so for high voltages, shielding of the thermoset, you can find it in section rule 36-104. Control and protective equipment 36-200, protection, control and protective equipments. Okay, let me to find most important questions in section 36. Disconnecting means. Okay, this can be a question. For disconnecting means, for high voltages, for disconnecting means, always remember rules 36-214. Subrule A. Provide with means of the adequate visible inspection all contacts in both open and closed position. Both of open and closed. In your exam, maybe one option is open should be, and maybe you think that, yeah, open should be visible because it's about the disconnecting means for high voltages. It's very dangerous. It's very important actually. Safety is about the safety. When you're working in a high voltage system, you need to be careful about the disconnecting means of that system. You need to disconnect that disconnecting means and then go to the work for the high voltage. So by the rule, they ask you that the contacts of the disconnecting means, even in open position, if the contacts are open, or the contacts are closed, they should be visible from the outside, from your side. They should be visible that even they close or they open, disconnecting means should be visible for the electrician, that the high voltage disconnecting means is, so both open or closed should be visible, not just in open position. Grounding and bounding as have high voltages. So table 51. This table, we call it table Ahmad. This table is table Ahmad table, and table 51. Let me show you here. Table 15, table 51, table 15, table 51. Table 15 is about the ready band for high voltages, but table 51, it's about grounding. Table 15, high voltages for ready band for high voltages, but 51 is about grounding conductor, copper grounding conductor, and it's about duration of the fault. Duration of it can be half a second or 1 second. 1 second or half a second. You can see these in your question, and also the joint, the name of the type of the joint, and also the ampacity of the amp of the short circuit. How much amp will pass the fault joint, the how much from the bare copper grounding conductor, how much short circuit current will pass from your bare copper conductor. In the case of 2K amp and half a second fault duration and exothermic welding, 1 aught. We need 1 aught American wire gauge. Okay, it is, and also this one is for, see here, look at here, section 36. Section 36 is about the high voltages. So table 51 is about the high voltages. All about the high voltages. Rule 36-300, Rule 36-308, Appendix B also. Okay, this one is about this table 51, and also, so you can memorize it better. Table 15, table 15, table 51. Both are about the high voltage. Table 15, high voltage, radiband, table 51. Again, it's about the high voltage. High voltage. Which section? Section 36. These two tables, high voltage, section 36, table 1-5, table 5-1. Just sweep the digits. 1-5, it's radiband. Table 5-1 is grounding. Grounding copper conductor. Copper conductor. Okay, so table 1-5, table 5-1. Table 1-5 is about the radiband. Table 5-1 is about the grounding conductor related to the high voltage, section 36. It's summarization for you, for easy memorize, because you need, because at your exam you don't have a lot of time to go to the tables and look at searching. You need to memorize all of these. So table 51, also we call it table Ahmad. Table Ahmad related to the grounding of bare conductors for the high voltage, section 36, and also table 15 related to the radiband. Okay. And also I already told should be disconnecting means even in both open or closed contacts should be visible. Grounding and bounding 36-300. Grounding and bounding are high voltages, and table 51 I told you about table 51 and how we can use it in your exam. And ground potential rise, maximum 5000 volts. Ground potential rise. So it's about the ground potential rise. And minimum size of the ground grid conductor, minimum size 2 odd. Minimum size of the ground grid conductor should be 2 odd. Touch and step voltage, table 52. So again, about the high voltage, section 36, section 36, about the high voltage. Section 36 is a very important section because you have a lot of questions from the section 36, and it's about the high voltage. And high voltage, section 36, table, which table? Table 52. Also table 52 is about the high voltage, and high voltage is about the touch and step. Touch, in your exam you can see these words, touch, if you see touch, or step. Okay, So if you see touch voltage or step voltage, you should be sensitive about these words in your, these are the key points in your exam, in your question. If you see touch voltage or step voltage, these are related to table 52, related to high voltages, related to section 36. So it's like this, bidirectional. So when you see touch voltage, step voltage, let me to describe it here. Ask ChatGPT. Describe high step voltage and touch voltage. These voltages defined in the high voltage stations on the top of mountain. It's not related to the actually electrical equipments. Maybe you are climber, you go to the mountains, top of the mountains. These are important also after lightning. Yes, for stations we have electrical faults in the high voltage stations, power stations, but also as a climber, as a nature, you go to nature, you go to the top of mountains. 20 years ago, this happened for me. Step voltage, this happened for me in at the peak of the mountain when it was lightning around me. Oh, it was danger. Okay, in high voltage stations, you need to be careful about the ground fault. When a fault happen, the fault can be happen from the power system or from the lightning. And the ground, this is the ground mesh. This is the ground mesh, and there is the resistance between this ground mesh and this. Because of that, they ask us in this book, you for the ground rods, at least minimum 3 meters in the same system, 3 meters from the ground rods. But this one is different. It's 3 meters is for the dwelling, and it's not for the high voltage station. It's more than, it needs more distance in high voltage substations. Okay, earth, potential, ground fault. Let me first definition. Step voltage. Step voltage is a voltage difference between a person's feet when standing near a ground fault. So we have a ground fault or lightning fault, and if a person is standing near that ground fault point, these photos are not good photo. I don't like these photos. Okay, when a fault current enters the earth, the voltage is highest near the fault and decreases with the distance. So when in the point of, let me to show here that one was not good. Okay, let me to delete this one. Okay, good. Now we have a fault point. Here we have a fault point. For example, 5,000 volt fault happened, or for lightning maybe 200
k volt. Touch the, and this is the ground level. Okay, so this is the ground. So we have circles around this point with different voltages, different level of the voltages, and the voltage go up with the circles, smaller circles. The voltage go up because the high voltage happened here, and the electrons, small part of the electricity, electrons, will expand here in the ground, in the soil. So the power, the high voltage, it's related to the how much that we are close to that fault point, because the distribution of electrons, distribution of electrons, E, the distribution of the electrons, a lot, million, billion, billiards of the electrons, a lot of electrons after fault, for example, in a higher station, power station, or from lightning when happen in a point, a lot of electrons, and they started to distribute in this soil. This is the soil, and the voltage, because of these electrons, the voltage is different between these circles. Lower voltage, so lower voltage, lower volt, so this side. So but still, from this circle to from this border, from this barrier, from this barrier, this is the different voltages. So if you put one of your steps here and one of your steps here, for example, one step here, one step here, you want to walk away from this fault point, you want to run from away from this point. So there is a different voltage between your feet, and it can kill you, because sometimes maybe a lot of different, for example, maybe this line is I don't know, in the case of lightning, it's 5K, and maybe this one is 4K. So between two of your steps, 1K difference between the voltage, and it's danger of the step voltage and also touch voltage. So let's come back here. Okay, fault point, we have definition. So, and when a fault current enters the earth, the voltage is highest near the fault and decreases with the distance. If your feet are apart, each foot may be at a different voltage level, causing current to flow up one leg and down to other. Example, a down power line falls on the ground. For example, fault point, it is the fault point, low voltage, high voltage, medium. So also left foot, right foot for 50 volts, and difference step voltage is 50 volts. Current can flow through the person's leg and body, so it is danger. Touch voltage is the voltage difference between an energized object and the ground where a person is standing. If you touch an object, a person touches a metal object that become energized due to a fall. Example, metal fence. If you touch a metal fence, 120 volts, person, ground 0. So 120 can kill you. Which is more danger? Generally, touch voltage is more danger. Touch voltage, because you start to run from the fault point, because the current path often goes hand, chest. Yeah, touch is more danger.
but step more happen, because most of the time you in fault cases, in these situations, you know that you don't you shouldn't touch the metals. Safety measures: grounding grids, so grids, grounding grids, bounding of metal parts, ground rods and electrodes, equiptional grounding mats, keeping feet together near down. Yeah, this one is important. In the lightning case, you need to walk very with with short steps, not long steps. Exam tips. Okay. And so table 52. Table 52 and table 51 is about the bare copper grounding, on the size of copper grounding, bare copper grounding for high voltages in case of 1 second or half a second, and in case of short circuit current. So we have short circuit current, we have a fault, we have a short circuit current, we want to pass this current, to the ground. It's a short current, and we need to know what is the minimum size of the conductor that it can pass this current to the ground. But after all, let me so table 51, this one is table 51. It's about the minimum size of the bare copper conductor for high voltage, section 36 high voltage. And then after this we have table 52. Table 52. Table 52 is about the variable touch and step voltage. So if you're in your exam, you see step or touch voltages, and you see half a second fault duration, 1 second fault duration, and the type of the soil. You need to be sensitive about these key points in your exam, and quickly choose the table 52 to solve this question. We have some notes in this table. It's about the weight of the body, 50 kilogram, and okay. And again, ground operation, switch handle, ground, high voltage couplers. Okay, high voltage couplers. So we have high voltage couplers. High voltage couplers. These ones. We use these couplers for high voltage plug and receptacle. High voltage couplers is a device used to join, connect, and disconnect high voltage cables or equipment safely while maintaining insulation and electrical continuity. It allows power to be transferred between the sections of the high voltage system. Common applications: underground distribution system, mining equipments, substations, high voltage substation, temporary power installations, high voltage motor connection, and so on. Functions: high voltage couplers connect two high voltage cables, provide between energized main components, conductive contacts, insulated body, stress control layers, protective other housing types, straight couplers, T-couplers, separated couplers. And we have a rule 36-400. It's about the high voltage couplers. plugs, receptacles, and bounding of them. And that is the end of section 36. Section 36. Okay. Now we can go to the section 38. Section 38 is about the elevators, and let me minimum headroom for elevators are 2 point working clearance. For working clearance is 2000 millimeters, 2 meter or 2000 millimeters, but minimum headroom is 2.2 for the elevators, and voltage for circuit voltage shall not exceed 300 volt voltage circuit in the elevators, 300 volts. And let me to tell you most important. No, I don't have a lot of things here. So after that, section 40, cranes. Section 40. So section 38 is about the elevators. No questions just in case you need to come and see it. Most of the time you can find it easy, no problem. But very less questions. Section, and also section 40 is about the crane and hoist. Just a table 58 related to this section. Table 58, if it's about the sizing of the cables for the electric cranes and hoist. So if in your question, in your exam, if you see that something related to the size of the cable, it's like table 2. How you find the size of the cables in table 2 is like that. But for 4 insulated conductor, table 2 is for 3, and it's for 1 or 2 or 3. But more than 3, you need correction factor for 4, for example. But for table 58 is for 4 insulated conductor, and is for crane or hoist motors, short time related, and ampacities. You have the ampacity, for example, 33 amp for 30 minutes. 33 amp for 30 minutes. The termination temperature is 75, and the cable can be used is number 12 American wire gauge. That's it. So this table, memorize this table, table 58, related to the hoist and cable sizing of the hoist and cranes, and also related to the section 40. Okay, and then next section, section 42, is about the welders, electric welders, and motor and generator welders, resistant welders. Also this, in this section, it's rarely you can see questions from this section in your exam. It's good to just come and check this section, be ready in case if they give you the question. Also, okay, section 42, welders, and then section 44 is about the theater installations. This one is a little bit more important in the questions. For portable switchboards on a stage, for example, what kind of supply portable switchboards, or one kind of conductors portable switchboards shall supply the flexible cords. This is the question. Rule 44-252. Rule 44-252. This is the question. Mostly you can see in your exam type S, SO, or ST, the cable that you can use as a flexible cord. And Okay, where you can find information about flexible cords, about the wet, damp, dry, extra hard usage, and oil. Where we can find information about the flexible cord, about the voltages, about their insulation. Okay, yeah, table 11 and table 19. These two tables related together about the flexible cord. Table 11 is about the flexible cords. Table 19 is about the other than flexible cords, but they are related together in these tables, table 11 and table 19. So for the theater, for the stage portable switchboards, you need to use flexible cords, and the type should be S, SO, and ST. Conductors. So where the conductor of the to the terminal, it shall be soldered into like. No, I never seen any question about this one. Okay, that's it. Let's go to the section 46. It's about the emergency power supply. Emergency power supply, and about the wiring method of emergency power supply, general rules, emergency power supply, definitions, and okay, rule 46-304, unit equipments. It's about supply connections for the emergency power. We have this one is question. I've seen this this question in the exams. Permanently connected for the emergency systems, for the emergency, when we can permanently connect an emergency equipment, when the voltage rating exceeds 250 volts. So when the voltage exceeds 250 volts, or the input rating exceeds 240 amp. So if the input rating of the amp is more than 24 amp, so if it is more than 24 amps, or the voltage is more than 250 volt, or be careful about the or, because or maybe the voltage is 120 volt, but the amp is 30 amp. So in this case, you can permanently connect the emergency supply equipments to the wall or to the job site, everywhere. So you can connect it to the, and you need to use flexible cord as an attachment plug for these devices. Not exceeding to the unit equipment shall be permitted to be connected with flexible cord. So you can use flexible cord. And voltage drop, remote lamps, this one. Also, this one is very important. Just one digit, 5. Rule 46-306 is about the voltage drop in emergency power supply systems. In emergency, in general, in section 4. In section 4, we talked about the. Please open your book and go to the section 4. In section 4, section 8. Section 8, rule 8-102, voltage drop. It was about the general. It is general rule, and we had 2 digits: 3, 5, 3, 5, 3 between the panel and load. 3% voltage drop maximum. 5% from the service. There is some interference of service to the load. 5%. But here for the emergency power lights, the maximum is 5% for emergency. Most of the time they are DC and low voltage or extra low voltage, class 1 or class 2. So the maximum voltage drop is 5 volts in this case for the emergency power systems. And if they ask how can they give you the question? For example, they tell you for a for an emergency light, we need how long can be the wire of for emergency light system, that the voltage of the system is 24 volts and the voltage is 24 volts and the wire is 12 American wire gauge. That's it. They just tell you the voltage of the system, for example 24 volts, and the gauge of the wire. So you can go to the table D3, but you need this digit, this number, 5% for the because they already told you that it is emergency light system. So you need to know that 5% is the voltage, maximum voltage drop. 5% for maximum voltage drop, and you need to go and check it. So for the emergency power lights, voltage drop, maximum voltage drop is 5%. Okay, maximum voltage drop is 5%. Okay, next section 52 is about the diagnosis, I imagine, installation, X-ray devices. Disconnecting means should be 100%, and transformer, capacitor, bounding, control, momentary rating, a rating that is applicable for the operating period of not more than 20 seconds. Line time rating 5 minutes. This can be a question. 5 minute line time rating, 20 second momentary rating, working of the X-ray or diagnosis, high voltage diagnosis devices, high voltage guarding. They need high voltage guarding, and that's it. So Fable 52 is about it was about the diagnostic X-ray, and take the table section 54 is about the community antenna, on radio and television systems. So in this section we have some Cat-V cables. So maximum allowable permitted amp for Cat-V systems are 10 amp. It's too much, 10 amp. So Cat-V cables. Cat-V cables. Okay. Cat-V cables. We use these ones, coaxial cables or Cat-V cables for community antenna, for the radios, for radio station, for television stations. And maximum, this is the question. I've seen this question because it is tricky question. They can make a trap for a lot of candidates, because most of us think that 10 amp is too much. if we couldn't find it in the book. So this one is question 10 amp, rule 54-102. So it can be a great question. 10 amp maximum amp that these cables can work on in this condition. For a building multiple occupancies, the open circuit voltage does not exceed 90 volts. So the voltage for this captive B, in these cases for the multiple occupancies, the maximum voltage is 90 volt for these cables, and the current is limited to 10 amp. So the current is limited to 10 amp, but the voltage limited to 90 volts. And cable distribution plant. Okay, we have another question. I've seen it a lot. Grounding conductor, rule 54, section 54, community antennas, Cat V cables, and Cat V grounding conductor. Grounding the grounding conductor. So the grounding conductor shall be not smaller than 15 gauge. So grounding conductor for Cat V cables by the rule 54-300 at least should be 14 gauge. 14 gauge for this grounding conductor, outer conductive. So how we connect the grounding conductors? We connect the grounding conductor to this shield, to this conductive shield of coaxial, to this one, and the minimum size of the grounding conductor should be 14 gauge. 14 gauge is the minimum size of the grounding conductor for this coaxial cables or Cat V cables. So this one, I've seen this question a lot. 14 American wire gauge, the grounding conductor for the shield of the Cat V cables. And grounding electrodes also, rule 54-302. The minimum driven length of the rod electrode shall be, so the rod for the conductive, for the community antenna system, like radio or television system, the minimum length of the rod that driven to the ground should be 2 meters. But it was 3 meters for the dwelling unit, for the power and lighting system. It was, at least it was 3 meters. You can find it in section 10. In section 10, if you go to the section 10, let me section 10, and minimum length of the rod, it was 3 meters. It was 3 meters for the minimum length of the rod. Grounding 10-100 and 3 meters apart. Grounding, we have 2 meters separate each other for the spacing, interconnection, grounding electrodes separated, but at least where there are multiple grounding electrodes. When we have multiple grounding separated grounding systems, the separation should be 2 meters between 2 different grounding systems, but in same grounding system the separation between the rods should be 3 meters. But I'm talking about the grounding at least 6 American wire gauge for the copper and 4 for the aluminum. Field assembled, manufactured grounding. Ground electrode shall consist of manufactured grounding in situ manufactured grounding electrode, field assembled grounding, and in situ grounding. So for the manufactured grounding electrodes, what's for to at least we need 2 rods, electrode rods for the dualing units, for the grounding system. And in field assembled, we need 6 meters of the grounding cable, and we can find it in table 43. For table 43, that's what is the size of minimum size of the grounding bare conductor that we want to use it as a grounding metal electrode on the ground, in the ground. And it should be 600 millimeters below finished grade. Okay, and okay, so and also we have one in section 10. In section 10 we have livestock access. Structure that live is conductive metal parts that structure that livestock as access. So livestock, if you've seen about your question about the livestock, animals, the cows, sheep, you can check the rule, and also appendix B, rule 10-700. So it was about just a flashback about the grounding because I've seen, but I want to talk about the rule 54. Let's come back to the section 54. 54 is about the community antenna, distribution, radio, TV substations, and TV stations. So 54-400. And separated from other conductors. So cables, community antenna cables shall be separated from the power or lighting power conductors, electric lighting, power, and class 1 circuits. So operates at 300 volts or less. So this kind of cables, they should be Cat V cables. They should be separated from the lightning, power, and class 1 circuits that they working under the 300 volts. So what is the minimum separation? If the voltage is less than 300 volts, the minimum separation should be 50 millimeters. So separation between the Cat V cables and the separation between Cat V cables and lighting and power and class 1 cables should be 50 millimeters. If the voltage is less than if the voltage is 300 volts or less, always 300 and less is the same group for 50 millimeters separation. But if it's more than 300 volts, the separation between the community cables like Cat V and the lighting or power or class 1 circuits should be, the separation should be 600 millimeters. 600 millimeters when the voltage is more than 300 volts, but the voltage, if the voltage is less than 300 volts, separation should be 5 millimeters for the Cat V or community antenna cables. But I have a question for you here. This rule 54-400 tell us that this rule is about the separation between the community antenna TV or TV or radio cables, like these Cat V cables, and lightning, power, and class 1 circuits. So class 1 circuit also, these cables should be separated from class 1 circuits. And also there is two cases, case on 300 volts and less than 300 volts, or 300 volts and more than 300 volts. So the separation should be 5 millimeters if the voltage is 300 or less, or 600 millimeters if the voltage is more than 300 volts. But this rule talking about class 1, but in this video early, when we were in section 16, when we talked about the section class 1, we had this limitation 30 volts for class 1. So the limitation, if you remember, the limitation for class 1 was 30 volts, and also for the volt amp of the class 1 was 1000 volt amp for class 1. But the limitation for class 2 was 150 volts. So the voltage of the class 2 was upper than the class 1. Class 1, the voltage limitation was 30 volts, but for the class 2 it was 150. But for the volt amp, the power, the limitation for the class 2 was 100 volt amp, but for the class 1 it was 1000 volt amp. But why in this case, in this rule, it tells us if the voltage is more than 300 volts for the class 1, the separation between the Cat V cable and the class 1 should be more than 600 millimeters. So why? When the voltage in class 1 is limited to 30 volts, why this rule tell us for more than 300 volts for class 1, the separation between the Cat V cables and class 1 cables should be 600 volts? Did you get my question? It is related to the section 16. If you go to section 16, let's go to the section 16. Please find out your book, section 16, and rule 16-100 class 1 circuits. Rule 16, please look at to the rule 16-100. Subrule 1, it was our definition. The limitation of the voltage for class 1 circuits are 30 volt and 1000 volt amp. So 30 volt and 1000 volt amp for the class 1 circuits. But there is subrule 2, class 1 remote control or signal circuit shall be supplied by source not exceed than 600 volts. So it is like an exemption for definition of class 1 circuits. Class 1 circuit, we define the class 1 circuits, the voltage is less than 30 volt or less. But there is an exemption for this class 1 circuits. In case of remote control or signal circuits, it can go up to the 600 volts. Because of that, here in section 54-400, we are talking about the separation between the Cat V cables. Cat V cables and the class 1 circuits, that if in case upper than 300 should be 600 millimeters, but in case of less than 300 volt or 300 volts, it can be 5 millimeters. Okay, that's it. And community antenna, copper conductor, minimum size of copper conductor should be 6 American wire gauge. Conductor outside building. Okay, conductors outside building. Cable. I mean that because these cables, Cat V cables, we use these cables inside and outside. You know, because we need it for outside. So there are some rules about the outside usage of these cables. So we need by the rule we need to permit everything by the section 12, because section 12 is about the general rules about the wiring methods for the outdoor. And let me to maybe find okay, this one is question. Rule 54-602, overhead conductors on roofs. It's talking about the roofs and overhead conductors. It says 2.5 meters. 2.5 meters. Please look at your book. Section 54 is about the community antenna. Rule 54-602 is about the rooftop, and it says that at least the cable, if we have because for antennas we use to pass these cables over the rooftop. So they said the rule tell us that it should be more than 2.5 meters above any roof that can be readily walked upon. So if you see walked upon in your if you see roof, walk, and also Cat 5 conductors or community antenna conductors, you need to choose the 2.5 meter in your options in your exam. So community antenna distribution cables passing over the building. So it means that on the top of roof, if the roof is in a way that maybe roofers or people or the owner need to walk on the roof. So if the Cat V cable, community antenna cable, need to pass up above the roof, at least this distance should be 2.5 meter. Okay, and finished here. Section 56. Section 56 is about the optical fiber cables. Optical fiber cables is section 56, and let me just tell you most important questions in these sections. So first of all, rule 56-200 is about, we have three different kind of, this section is about the optical fiber cables. Let me to first continue about this. Cat V, standard community antenna television cable, coaxial cable, used coaxial cables distribute television signals, internet services. In the past, early days of the internet, they used to use these coaxial cables for internet services, but not now. In every houses, in dwelling units, in apartments, if you go to the old neighbors, you can see internet service cables that they use the coaxial cables, but not now. Nowadays they use fiber optic cables for communication for the internet. Cable modem communications, they use to video signals. But nowadays we also we use these coaxial cables for video signal, television, and sometimes for radio stations. Okay, construction of Cat V cables, a typical cable consists of outer jacket, shield, insulation, dielectric, center conductor. Okay, common types RG6, common types of the coaxial cables. So it can be in your question because I've seen this in the exam. You need to know that what is RG, and just try to not memorize, but if in case in your exam you've seen, you need to know that RG6 is a kind of Cat V cable. Most common for residential cable, TV and internet. So RG6 is most common for residential. Better signal quality range RG950. RG59 used for shorter runs and some CCTV systems, higher signal loss than RG. So this better conductivity, RG60, less resistance. But RG56 is for shorter runs, for short run. RG11, larger cable used for long distances, lower signal attenuation. So attenuation, and also what is attenuation? It was a question. What is definition of the attenuation? It was a question in the Red exam. Electrician 309A, construction, electrician, journeyman, advantage. Good shield against interference. So the shield, we use shields for interferences. Can carry high frequency signals, durable and reliable, support TV, internet, data, everything. Typical installation, homes, apartment, commercial, cable TV, and that's it. Okay. Now, after Cat V cables, after CC section 54, these two sections related together. 56. It's about the internet communication, but it's optical fiber cables. Optical fiber cables, we use light modulation. We use light modulation for optical fiber cables. We have light cores in these cables, and we send the transmitters use the light transmitter use light for communication, very high capable, a lot of data can pass through these optical fibers. Okay, but in rule 56-200 installation methods, we have three different kind of cables that they define: non-conductive optical fiber cables, conductive optical fiber cables, and hybrid cables. It doesn't mean that the cable, inside the cable we have the light, but it is about the shield of the cable. Non-conductive cable is the shield of the cable, and conductive. So we have a lot of questions in exam for this one. Non-conductive optical cables. Non-conductive optical cables shall not occupy same raceway with insulated conductor, electrical lighting, and class 1. So non-conductive fiber cables, we can put them in the same raceway that we have electrical lighting, power, or class 1. Unless we have some unless cases. The non-conductive cables are functionally associated with electrical lighting, power, or not exceeding 750 volts. So if the voltage is less than 750 volts, we can run the non-conductive optical fibers with the class 1 or lighting or power system. The number and size of the non-conductive cable, other type of the necessary conductive, and meet the application required wiring method. Okay, not important. non-conductive cable shall not occupy the same cabinet panel, similar enclosure housing of the lighting power class 1 unless the non-conductive optical cable are functionally associated with the lighting. Okay, so we can use them if the lightning power or class 1 circuit not exceeding of 750 volts, and also the non-conductive optical cables are factory assembled in the enclosure. In this case also we can use at the same enclosure. And also if only authorized person service install this service, they can permitted at the same raceway with at the same raceway. So also authorized person, only authorized person can do this. It was a question. Authorized person can install non-conductive optical cables in the same raceway with lighting or power or another kind of class 1 circuits. But conductive optical cables. For conductive optical cables, rule 56-202. Generally, we can just use these conductors at the same raceway with class 2 circuits. So for conductive, for non-conductive, we can't put them in the same raceway. Just it has some exemption. In these cases, we can install the non-conductive optical fibers in the same raceway or box with the class 1 or power or lighting systems. If the voltage is less than 750, if the voltage is 170, we can do it, or if they install with the authorized person, or if they go for the same for a device that device needs both of them, we can do it. But for conductive, generally we just can run at the same raceway with the class 2 circuits. The limitation of class 2 circuits was 100 volt amp. So for conductive optical fiber cables. And section 60 coming. Class 2 circuits according with section 16, so they can run with the same enclosure, depend on section 16. Communication circuits in accordance with section, so we can run conductive optical fiber cables with the communication circuits that they related to the section 60. So still we can run the conductive fiber optical cables with the class 2 section 16 and communication circuits section 60, section 16, section 60. And also community under distribution with Cat V cables section 454, TV and Cat V cables, TV and radio. And also we have hybrid cables. We can it's permitted that run the lighting power and class 1 cables with the hybrid cables at the same raceway, but if they are not exceed from 750 volts. So in the case that they are not exceed from 750 volts, we can run them in a same raceway. Okay, so that's it. Just one page. This one page, I've seen a lot of questions from the section 56 It's about the optical fiber cables from the section rule 56-200. And section 58, passenger ropeways. Passenger ropeways. Okay, the voltage, the RMS voltage should be not exceed 30 volts for the for the working condition for the one or more following equipments in live parts removal. Caution label is applied. Voltage applied under unguarded or uninstalled parts shall not. Okay, for the voltage for unguarded voltages, for the parts that for passengers, maybe people touch the voltage, should be not exceed of 30 volts RMS or 42 volt peak. So 42 volts peak and 30 volt RMS. And you know how to convert the peak voltage to the, because this one is question. In your exam, you have a kind of conversion between the RMS voltage and peak voltage. The point is 1.44. The correction factor is 1.44. The coefficient is 1.44. So the RMS voltage, if the multiplied by 144, it gives you peak voltage. Okay. Protection and control, branch circuit, section, messenger. Okay, again, section 60 is about the communication, electrical communication systems. And here also you have some questions. For example, rule 6-308 is about the separation from other insulated conductors. Again, about the communication systems. The wires, if we want to put them in a same enclosure with the conductors like class 1 or lighting or power, the minimum separation should be 50 millimeters if the voltage is less than 30 volts, 300 volts or equal to 300 volts. The minimum separation should be 50 volts, but if the voltage is more than 300 volts, the separation should be 600 millimeter for communication systems, electrical communication systems, section 60. Okay, and we have one more thing about the communication systems. Where the light or power conductors are bare, all communication cables in the same room or space shall be enclosed in a grounding metal raceway. So if we have communication systems, cables, that they are in the same room with the bare power and lighting conductors, the communication system should run in a box or raceway or enclosure, that the metal enclosure should be bound to the ground. Okay, and if it is outlet box shall be permitted located within 2 meters of bare conductor if up to and including 15 kilovolts. It was the question. I had this question. So for communication circuits, if the distance between communication system conductors and the bare conductors of lighting or power system, that the voltage of that power system is less than 15 kilovolt, the distance should be within 2 meters. If they are in a such as outlet box. and above 15 kilovolt, above within 15 kilo the 15 kilovolt or less should be 2 meter, but above 15 kilovolt should be 3 meter. For the communication system, rule 60-308, sub-rule 2. It was question. Okay, so another question 6-400, it's about the equipment, and 6-400, this one also was a question. Communication equipment located in a bathroom shall be permanently fixed on the wall and shall be located so that no part can be reached or used from the bath or from the shower enclosure. So it was a question. For example, how we can have telephone line, landline in a shower. So they tell us that in this case, my client is asking for the website. Communication equipment bathroom, so they need to be installed, fixed installed in case out of the bathroom or shower enclosure, fixed that they can't use or they can't be in the shower or bathroom. So it was a question. Rule 60-400 is about the communication system and communication equipment and how we can install telephone landline or telephone equipment in a bathroom or shower. So it should be installed out of the range of enclosure of the shower. And okay, rule 60-600 direct buried system. It's about the communication system, direct buried system, how we can install communication systems as a direct buried, and the rule 660, the horizontal separation of 300 millimeters from the other ungrounded system. So for communication system, always remember this 600 millimeters horizontal separation from other undergrounded system. And about the 600 millimeters below the grade, it should be below the grade. But most important table here for this rule, you can find everything in this table. If you had any kind of question in this in this part about the direct buried cables, you can go and check table 53. So instead of this rule, you can use table 53 because it's easier. You can use table 53 for different part of this book. It's maybe 3-4 questions you can answer with table 53. Table 53 because you have different kind of cables not having sheet or armored, or having, if your cable, you can check the cable. How you can understand? Most of the time you know that or they say you in the exam, in the question, that the cable has sheet or not. But also you can use table D1 if they didn't mention that the cable has sheet or not. So you can use table D1 to check if the cable has a cover, metal cover sheet or not. So in this table D1, table 53. You have two rows if it is covered by metal sheet here or not here, and also if it is in vehicle area or non-vehicle area, or if it is low voltage or high voltage. So different kind of choice, and you can use this table for what? For direct buried cables. So for direct buried cables, always you can use this table, and it's working for not just for section 12. This table working for a lot of sections, because about the communication cables you have you can use this table, direct buried communication cable. For the optical not optical fiber cables, for the Cat-V cables also you can use table, and for communication table 4 section 4 also this table is useful table. Okay, and okay, so we're in section 60 and communication 6. Please always when you're watching your my videos, please open your book, physical book, because at your exam you need this book for the for find everything. You can't search it in Google, you can't search in PDF file or ask ChatGPT. You need to touch the book, you need to be familiar with the book. So please go and buy the book if you don't have it. So for the grounding of the communication system, please look at the rule 60-704. It's about the grounding of the communication system. I've seen not a lot of questions, but I've seen questions about this table 59. So for this rule we have table 59. This table is for the grounding of the communication. Table 59. Table 59. Open your book and look at to the table 59. Table 59. So table 15, minimum size of the protected grounding conductor for the communication system. You have two different, let me to show you here, table 59. Protected grounding conductor for communication system. When you need grounding for communication system, in two cases, fuse or unfused. Fuse or unfused. In your exam, in your question, you can read it that if it is fused or unfused, the system, communication system, they write in your question. And also they tell you how many circuits, how many communication circuits do you have in your system. Maybe they tell you one circuit that you want to protect it, and it is fuseless. So minimum size of the conductor you can use is 14 or 16. If 16 circuits, 16 protected circuits that they have fuse, minimum size of the conductor is 12. Table 59 is about the grounding cable of size of the grounding conductor for the communication system. So it's about the so till now in this video I've introduced you table 43 for grounding. We use table 43 to find out that what is the size of the grounding conductor for a short circuit amp. if you have a and it depends on the amp that how much ampacity needs to pass through the grounding conductor. And also table 51, it was about the short circuit conditions in high voltage substations, and it depends on the duration of the fault, half a second or 1 second. Table 51, so you can find the correct size of the conductor. And also table 59 is about the grounding conductor, but for communication system. So table 51 for high voltage, table 59 for communication system, and table 43, it is about grounding for general rule. It is about section 10, related to the section 10. General rules about the grounding system. So table 59, grounding cable for communication system. Table 51, grounding cable and short circuit for high voltage system. Table 43, grounding electrodes for field assembled system. When we want to do field assembled system, we use table 43. It's very important to memorize the name of the tables and memorize the usage of the tables. Also, one more thing, table 2 is equal to table 58. Actually, table 58 is equal to the table 2. You know table 2, but table 58, it's for size of the conductors in a crane or hoist system. So table 58, it's related to the section 40. Section 40 is related to the crane and hoist system. And from table 58, like table 2, you can find what is the correct size of the conductor. You have the, let me to show you, let's close table 58. Okay, so table 50 ampacities for the 4 insulated copper. So table 2, it was for 3, 2 or 1. Here is 4. And for crane or hoist motors, and like table 2, you have termination temperature for 75, for 90, but not 60. In table 2 we had 60 degree, but here 70, and this is different with table 2 because it depends on the duration of usage of this crane or hoist, 30 minutes or 60 minutes. So the ampacity, different ampacities, and in your exam they tell you the termination temperature, the duration of the usage, and also the ampacity that the hoist motor they use it. Or maybe you need to go and check the table 44 or 45, and you can find the size of the conductor in this table 58. Okay, let's come back to the section 60. Section 60 was about the communication. We were in rule 6-60-704, that it is in table 59, and table 59 can cover the size of the grounding for the communication system. Grounding for the communication system, table 59. And section 62. Section 62, it's about the fixed electric heating system. Section 62, it's about the fixed electric heating system. So let me to say which kind of questions you can find here. Terminal connections, length of the tap conductor shall not less than, okay, for rule 62-108, I've seen this in the exam. What is the minimum size of the tap conductors for the heaters, for the electric heating system. It's 500 millimeters. 500 millimeters is the minimum length of the tap conductor for heating system. For heating system, tap conductor minimum length is 500 millimeters. And this one also, rule 62-112, it was questioned. It is about the temperature of adjacent combustible material. If you have a heater and close to it, next to it, you have a combustible material, so it shouldn't go upper than 90 degree Celsius. So the maximum temperature can be not exceed of actually, if the temperature can exceed of 90 degree, the material, the combustible material, not to be in touch of this temperature more than 90 degree. Heating device shall be installed so that any adjust combustible material shall not be subjected to a temperature in excess of 90 degree. So it is the maximum temperature for the combustible material. Okay, one more thing, rule 62-118. It's about the percentage. It's related to the section 8. When you calculate the demand of the dwelling unit, apartment, or you calculate the section 8 calculations, when you have space heating heaters, electrical space heating heaters, we have two different cases. If that device, space heater, electrical space heater, if electrical space heater has automatic thermostat, so if it has automatic thermostat, for the first 10 kilowatt of that device, we use 100 demand factor, 100 of the demand factor. Let go to the section 8. Please go to the section 8 and look at to the rule 8-200, single dwelling. So in this case, in sub rule 1, 2, 3, 4, space heating 3. Any electric space heating loads provided demand factor permitted section 62. So this rule refer to the section 62. If it's old space heater, electric space heater, if it is old and it doesn't have thermostat, so in this case we use 100% of that kilowatt for this. In this case, we calculate 100 for the calculations of the load. For example, if the load of the space heater is 15 kilowatt, so we calculate 15 kilowatt in our calculations for load calculations of the dwelling unit. But if it has automatic thermostat, for the first 10 kilowatt we calculate 100%. So for the first 10 kilowatt, in the case of 15 kilowatt, so we have 10 kilowatt, but the balance of the connected heating more than 10 kilowatt, we calculate 75%. So for the 5 kilowatt, we multiply by 0.75, and This is for in case of that the device has automatic thermostatic control device. For the first 10 kilowatt, 100%. For the more than 10 kilowatt, 75%. And also rule 62-210. It's about the installation of the heating fixtures. For the installation of heating fixtures, the weight of the heating fixture is important. For example, sub rule 3, heating fixture weighing more than 4.54 kilogram. For this, in this case, shall be installed so that the wiring connection is to the outlet box or equipped will be accessible inspection without remove the heating fixture support. So if the weight of the heating device is more than 4.5 kilogram, we need to install it like in using an outlet box, that when we want to have inspection about the device, we don't need to remove the heating fixture. So this one is also, I have seen this about the kilogram of the heating fixtures and how we can install them in the questions. So in your question, depend on the question, you can check here. Okay. And maximum time setting 1 hour. This one also it was question. Maximum time setting for the sauna heater controlled by the time cut off switch. Maximum time should be 1 hour. Rule 62-222 heater for sauna rooms. Subrule 4. Maximum time should be 1 hour. It was a question. For sauna heater, maximum time should be 1 hour. Okay, and now section 64. Renewable energy system, solar, wind. So what is inverter? What is inverter? Inverter is a device that we use it in renewable energy systems. Inverter convert DC voltage to the AC voltage, because in the most renewable energy system like solar, like wind turbines, like every kind of these systems, we have DC that we need to convert it to the AC, so we need inverter. And what is rectifier? Convert AC to the DC, because in some cases we need to charge the batteries, so we need, in some cases we need rectifiers. So what is the rectifier? Convert AC to the DC. Rectifier, we use rectifier to get the power from the city and convert it to DC and give it to the batteries. But in reverse, we use inverter to get the power from the batteries and convert it to the AC and give it to the home. So we have definition of large, let me to find it, more than 100 kilowatt, more than 100 kilowatt system output, more than 100, and more than 100. Oh, okay, I found it. Wind. So for wind, large wind, this is, you need to know this one. We have two different kind of wind system. Large wind system large wind system output exceeding 100 kilowatt. So 100 kilowatt is important number for the wind turbine system, large wind system. Again, if it is 100 or less, it's one group, 100 kilowatt or less, we call it small wind system. We tell it small wind system. If it is more than 100 kilowatt, it's large wind system. And it's important because in the wind system we use this definition for different. So 100, remember 100 kilowatt for the wind system. We need it for the wind system definitions, and and you can see this system in the questions. Inverter maximum. Let me just see solar system. The voltage in solar system not to be exceed 600 volt DC between any two conductors. So this one is question. I've seen this question in the exam, 600 volt DC. So memorize this one, 600 volt DC for the solar system between the two conductors, and also any conductor to the ground. 600 volt is the limitation of the volt in the solar system. And 30 volt. 30 volt is another limitation for the metallic raceway metal enclosure for the solar system. And also voltage to ground maximum 150 volts. Voltage to ground, all energized pies and photovoltaic sources and output circuits over are accessible only to qualified persons. So if the voltage everywhere is more than 150 volts, it should be accessible to just qualified persons. And also, let me find more questions. Okay, small wind system. Rule 64-300, small wind system. And large wind system, 64-400. So the limitation is 100 kilowatt. Okay, section 64. Section 66 is about the amusement parks, windway, carnivals, and TV. Section 66, single conductor motors. Section 68 is about the pools and tubs and spas. So Table 61, underground wiring, raceway, pool, and we use table 61. Table 61. Let me this table. We can use this table. Horizontal separation from pools. This section is very important because there are lots of questions from this section table. For example, on jacket cable, bare neutral conductor, semiconductor, 1.5 meter separation from communication conductor. Or if they go inside the if they have jacket or they are in raceways, the separation is 1 meter. So separation from the pool and horizontal separation from the pool and direct buried underground cables for different systems. This section is very important because I've seen a lot of questions that they are talking about communication conductors and their separation from the pools. Also, power cables and insulated conductors depend on the voltage and their separation from the pools. For example, 3 meters. I've seen this question, it was questioned. 3 meters, the separation from the pools. So this table can be very useful. Table 61, don't forget it. The horizontal separation between the pools and direct buried underground cables. Table 61. And pool bounding for the pools, the minimum size of the bounding not smaller than 6 AWG for bounding for the pool system. Also receptacles. Receptacles shall not be located within 1.5 meter of the inside walls of the pools. So in the wall of the pools, minimum distance should be 1.5 meter for the receptacles. And the voltage, RMS voltage, 75 RMS voltage for the audio output system for the pools. In the pools, the maximum RMS voltage for the audio system is 75. It was questioned also. And between the 1.5 meter, so if you have pool, it's a pool and there is a wall, so between 1.5 meter we can't install any kind of receptacle. So between the pool and the this is the pool, this is the wall, and on the wall we want to install receptacle. And between one and let me to on here. Okay. Now we have pool. And beside the pool, this is the wall of the pool. Beside, we have a wall here. So in the distance of 1.5 meter, 1.5 meter, receptacle are not allowed. Receptacle. These receptacles inside and within 1.5 meter, 1.5 meter receptacle are not allowed with the distance of 1.5 meter. Not allowed. Okay, by the which rule? Rule 68-064. So rule 68-064. Okay, this rule, receptacle shall not be located within 1.5 meter inside wall of the pool. So 1.5 meter is not allowed, acceptable. But between 1.5 meter and 3 meters.
if the var go like this, and between between 1.5 meter and 3 meter, here is 3 meters. Okay, here between 0 to 1.5 are not allowed. Here we can use it. Here we can use it. Here we can, no problem. But here it's optional. It's conditional. Conditional by GFCI, ground fault circuit interrupter, class A. So GFCI class A. GFCI class A. So this is the rule 68-064. If we have pool, we have valve within 1.5, receptacles are not allowed. Between 1.5 and 3 meters with GFCI class A, and after that, no problem. And it is question. It's important for the exam. Okay. Let me go to the section 70, electrical equipment, factory build. Okay, minimum size of the trade size, minimum size of trade or raceway, like conduits for the temporary buildings, for the relocatable structures. Section 70. It's about the electrical requirement, factory built relocatable structure. And this one, it was question, I've seen this question a lot. Trade size 16 or larger, minimum size. So for what? For communication services like telephone, landline, like internet. If we use internet by the cable, Cat-V cable maybe, or optical fiber, minimum size of the conduit or raceway that we install for the relocatable or remove or temporary rooms, it should be 16 trade size, and projected from the projection minimum 75 millimeters through the floor. Okay, and so minimum size of the conduit, it was a question from this section. I've seen this question a lot. 16 is the minimum size of the conduit that we can use for the communications wires for the temporary or relocatable structures, or this kind of houses that we can move them. And also another question, rule for this section, another question that I've seen it is section rule 7-130, rule 70-130. Please look at 70 dash. Always when you watching my videos, please look at to your book, because I want to be familiar with the book, because I want you to be familiar with the book, because at the exam it's very important. Don't use the PDF file or search the Google or use the ChatGPT, because
because you need to know about the book, because at the exam you just have book and calculator and pen, that's it, and you don't have any access to anything. Rule 7-130 is about the AC and DC. Subrule 1 is about the DC, subrule 2 is about the DC, and it's about the tests, different kind of the tests that we need for the rule 70-130. It's about the different kind of the tests that we use for this kind of houses, factory built, relocatable structural houses. And sometimes in your question they write it like marine temporary wiring for what? Airport, mobile homes. Oh, okay. So sometimes mobile home, they in your question you see mobile homes, and you go to the mobile homes section and you can't find anything about the this rule, because this rule about the tests are in this section. Relocatable structures, factory builds, because sometimes it is like mobile home. So for the DC test, we apply 500 volt DC for the DC test, but duration is 1 minute. So when we want to test when we want to get electrical test for the relocatable structural homes or mobile homes, we need electrical test. If we test it with DC voltage, we test it for 1 minute and 500 volt DC. But if we test it with AC voltage with 900 volts, we test it for 1 minute. But if we use 1080 volt, we test it for just 1 second. So for the DC we use 500 volt for 1 minute. If we test it with AC, if we test it with 900 volt AC, here 900 volt AC, if we test it, different cases. This one, subrule 1 is for DC test. This one is for DC test. If we test it 500 volt DC test, it's just for 1 minute. If we test it with AC, if in case of AC 900 volts, we test for 1 minute. Or if we test it when 1080 volt, we test it for 1 second. Ground test of the factory built relocatable mobile homes. And okay, section 72, mobile homes and vehicle parks, recreational vehicle parks, mobile homes. There were some questions about the receptacles. Rule 72-102. It was about the receptacle and the calculation loads of the receptacle and vehicle, how much the vehicle needs, what is the load size of the vehicle, and depend on that we need to choose the right receptacle here. So it was question, for example, if it is 2.4 kilowatt, if the mobile home need 2.4 kilowatt, we need
this receptacle
for charge it or for use it or charge it. Okay, and section 474, it's about the airport installations. For this section 474, airport directory transformers. Yes, this one. Directory transformer need to be minimum depth 450 millimeters below grade. This one, it was question about the directory transformers for the airport installations, and also wiring method. And also I've seen this question, wiring method of the rule 74-004, and you can come and check what is the minimum depth or how much you need to directly the cables for the airports. And then section 76, temporary wiring. Temporary wiring, branch circuits. Don't have any kind of question in my mind about this section. Let me 200 volts, not exceed 200 over mounting signal pole, service entrance equipment. I think it was question. Rule 76. Yes. Right. This one, it was question. I've seen this question. Service entrance equipment be accessible to authorized person. So the service equipments for the temporary wiring, if we want to do temporary wiring, it should be accessible to authorized person, and they need to be locked, capable of being locked, and also not exceed 200 amp. So for the temporary wiring, the service cannot exceed from the 200 amps. Actually, we can't give a service for temporary wiring systems more than 200 amps. So these three, I've seen these three questions, different, separated question. It was this one the question, it was one time this question, and this one question, another question. So authorized person for temporary can accessible the service, and also the service capable of the lock, and also not exceed 200. Okay, and section 78 is about the marine structures or floating or boats. And this one, let me to find, it was about the receptacle that we can connect them to the, and also it was about the corrosive grounding. Let me to find what was the grounding and bound. Yeah, yes. So grounding and bound 78-058. For grounding and bounding, it is important if installed area subjected splashing or salt water, because splashing or salt water or salt spray, they can damage or defect the grounding cables. So minimum size of the grounding cable in this case should be 12 American wire gauge. So for the marine system, if they are in the installed area subjected, that they are subjected to the corrosive salt water, so they need to be at least 12 American wire gauge. And also demand factors, also because sometimes we need to connect these devices to the receptacles. Rule 78-054. It is the minimum size of the receptacle, and how many percent of the receptacle that we can use for the marine systems with how many receptacles. It was question, rule 78-054. And section 80, cathodic protection. So for this section 80, I just seen this question. It's about the disconnecting means. disconnecting means of the cathodic protection. It should be within 15 meters rectifier of cathodic system. This question, oh, also I had this, it got question, this one was question. Disconnecting means should be within 15 meters. Disconnecting means of rectifier for cathodic protection system. So cathodic protection system, we use cathodic protection system. Let me to ask here, what is cathodic protection system? It can be general rule, general knowledge. So what is the cathodic protection system? So we have a section about this, and cathodic system, we have some metals. We use these metals close to the wireways or conduits, metallic wireways and conduits, that they are underground, because ground can be corrosive for these metals. So we use cathodic system to protect the metals, steels, aluminums, and everything from damage. Definition: a cathodic protection, cathodic CP system, is a method used to prevent corrosion of metal structures buried underground or submerged in water. Also, they use it for the ships, vessels, and on the oceans, in the oceans or seas. It works by making the structure the cathode of the electrochemical cell so that it does not corrode. Why is it needed? Metal structures such as underground conduits, for we want to protect these conduits, or steel pipelines or storage tanks. Also, for these ones we use cathodic system, but let me I want, oh, rectifier, maybe it's this one. Yeah, this one is rectifier. So rectifier, this rule 80. So for the cathodic system we need rectifier to produce power for the cathodes. So this rule 80-10, 80-010, 80 disconnecting, this one. So the separation disconnecting means shall be installed to the point readily accessible to sight of and within 15 meters of the rectifier. So we need to install disconnecting means within 15 meters of rectifier for the cathodic system. And also this one, DC conductors, wiring method for DC conductors. So this one was a question, mechanical protection. They need mechanical protection and be in the raceway, and the wiring below ground, if we have, because we have wiring below the ground, and 450 millimeters or 200 millimeters were installed in a raceway or mechanical protection. It's talking about these wires underground. Okay, so this, it was the question. And also this 200 can be question. Each number, each definition in this book can be a question. But some question, because they related to the safety, they related to most important things, so they ask more. Here I try to talk about the most important question. So section 84. Interconnected of electrical power induction sources. So it's about the interconnection of electrical power production sources interconnection, against back interconnected power production feed. Let me this interconnection of the electrical things, scope, loss of supply of gravity voltage. No, I don't have anything from this. Okay, section 86, EV charger. EV charger, and table 7 is about the radi bend for the conduit or tubes. Table 15 also is about the radi bend for the high voltage cables. It was not in this section, but I just remembered. Okay, let me to talk about EV section. EV section. Okay, this one. It was question. Branch circuit, separate branch circuit. Control and protection. Ventilation equipment. Okay, no other load except ventilation. So except permitted subrule, electric vehicle supply equipment shall be supplied by a separate branch circuit. So they need separate branch circuit. And also disconnecting means, this one also it was question. A single disconnecting means shall be permitted to control 2 or more electric equipment assemblies. So disconnecting means should, at least they should control 2 or more, but the question supplies same branch circuit, provide each electrical equipment assembly by itself does not exceed the rating of 60 amp. So in a branch circuit, the branch circuit should not exceed 60 amp in a branch circuit. Maybe we can use 2 branch circuits, but in same branch circuit, maximum ampacity of a branch circuit for an EV charging device should be 60 amp. And single, okay, which kind of receptacle we use for single receptacle for EV system? This, it was the question 5-20R, 5-20R, that 5 related to 125 volts and 20 is, it means 20 amp. Here we have it. Diagrams, diagram 1 here. So diagram 1, non-locking receptacles, it was 5-20 amp. 5, it means 120 volts, it's like this, and 20 amp. So the receptacle for the EV charging should be like this. This one, the receptacle. In your option, in your exam, maybe they just show you this the shape of the receptacles. So, and R means receptacle, so it says the shape of the receptacle, not plug. If here you have P, it is about the plug, but here if you have R, it is about the receptacle. In your exam, I have seen this question. Just they give you this shape of the receptacles, and you need to choose the right receptacle for the EV charging system. You need to know. You need to first come and check the which receptacle is useful for 2-20R, and then go and see which one is the right receptacle. Okay, and that's it. Okay, and table 7 is about the conduit. Let me, table 7. 7. Ready band for the conduit and tubing bands. So here you choose the size of the conduit, for example, conduit size 53, 27, 21. And then minimum radius of the center of the conduit tubing. This is the band, accepted band by the rule. And table 15 is about the high voltage cables for the ready band. Okay, and table 15. Table 51 related to the high voltages. Table 15 is related to the high voltage system. Table 15. Table 11. Table 11 is very useful table in your exam because you can see what is which cable you can use for dry places, damp, wet, not for hard usage, extra hard usage, exposed to the sunlight. For example, TEW is not a cable that you can use it exposed to the sunlight. Which cable here? Cable, let me, okay, for example, these cables, SJTW, you can use it when it's exposed to the sunlight. So table 11, still table 11. So table 11 is about the flexible cords and their usage, how we can use them, where we can use them, which conditions we can use them, for which voltage, also voltage rating. And also we have table 19, that that table 19 is like this table 11, but that table 19 is for other than flexible cords. Table 12 also is for flexible cords, but it's like table 2. We use table 12 for flexible, for these special cables, flexible cables. But when we have the ampacity, it's like table 2. We have the ampacity of this cable, and we can find which size of the cable we can use. For example, for 25 single phase, 25 amp. If we need a single phase motor that we need, like for example STW in the flexible cord, we can use 12 American wire gauge. So I want to go for the table 13. Table 13. So we use table 13 after do the calculations for the conductor, for the circuit breakers, for the fuses, non-time delay fuses, time delay fuses, and we use table 13 for get the standard size of the fuses. And table 14, we use table 14 related to the section 8. It's about the calculations of demand factors for table 14 for different kind of occupancy. For example, office, 50 watt per square meter. For church, for example, 10 watt per square meter. For banks, 50 watt per square meter. So you can multiply this 50 by the square meter of the bank. For example, if the bank has 200 square meters, so multiplied by 50, it's 10 kilowatts. And table 15. So table 15 is about the bending ready for the high voltage cables. And we have portable power cable less than 5 kilovolt or 5 kilovolt, and 6 times if the cable diameter is up to 25 millimeters, if the diameter of the cable between 25 millimeters and 50 millimeters, if the diameter of the cable is more than 50 millimeters. You can find it in table 15. But also table 51, this table is 15, but if you reverse the digits, table 51 is also related to the section high voltage. This table is related to the section 34 and 36. Section 36 is related to the high voltage. But table 51 also, I'm telling this for make it easy to memorize it. Table 36, section 36 is about high voltage, and table 15 related to the high voltage for the bending radii, but also table 51 is related to the high voltage, but it is for calculation of the grounding cable, size of the grounding cable for the high voltage substations and ground faults in the short current fault. Okay, and okay, the review of the sections of this book finished, and next time I'll review all the tables, maybe some tables. I tried to review also, I already covered the tables of this book in between the sections, but still there are some tables that they are important, and we need to put more attention on them because they are using in the exam. Okay, so yeah, for this time I want to have a quick review for here. It's about the general knowledge. Okay, outlet and receptacle symbols. Singlex, duplex, receptacles. These are receptacles: single, duplex, triplex. Okay, if they have GFCI, USB, waterproof or weatherproof, weatherproof or waterproof receptacle. And also these ones, probably don't need these ones. Okay, again, recessed light fixture for recessed light fixtures, wall mounted fixture with this line, switch if they have pull switch, ceiling pull switch, junction box, vent fan, ceiling fan. If 2 dash, it's like 2-wire cable, 3-wire cable in this case. 3-way switch, S3 is 3-way switch, 3-way switch, 4-way switch, single port switch. So weatherproof switch, GFCI if we have GFCI, or maybe AFCI, arc fault. And FAS 90 cable. FAS 90 cable, mostly we use it for fire alarm system. IMC EVT intermediate metal conduits, intermediate metal conduits. We use this cable. They have threads like EMT. Okay, and this one, wire ropes. And some questions, maybe you can see wire ropes. These are wire ropes, and wire rope thimbles. Wire rope thimbles. We use. I've seen a question that it was why we use wires, or which device we use for protect the wireways. We need to choose wire rope thimbles. wire rope. We use thimbles for protect the wire ropes. And this one, wire rope clip. We use wire rope clips to tie the wire ropes. This lateral face, this face, it is about the VMS questions, general knowledge questions that related to the scaffold. When we have scaffold, if the height of the scaffold is more than 3 times of the width of the scaffold, we need to use some lateral faces, more lateral faces to protect the scaffold. So the question like this: 3 times the smallest lateral base dimension. What is the maximum allowable height of the freestanding or rolling scaffold before using special devices for safety equipments for the scaffold, freestanding scaffold? Maximum 3 times highest lateral base dimension. It means that this height maximum, it can be 3 times of the width. And here Scott T connection, it's a kind of transformer. We call it Scott T. We have two we use 2 different transformer, teaser transformer and main transformer. The important thing about these are teaser working at 86% of the power, but main transformer working at 100% of the power. So you can see some questions related to this 86% and 100%. Main transformer 100%, teaser 86%. Messenger cables like these ones, they use steel wire rope as a messenger. When the cables, they have small size of the conductor, copper conductor, like these messenger cables. Hoist hand signals. For these questions, this hoist, lower, emergency stop, these are most important. Multiple trolling, no. Emergency stop, lower, hoist, these ones. More, hoist up, lower. Use main hoists. Use wipe line. Which one? Let me, emergency stop. Swing, maybe. Okay. And toggle bolt, these ones toggle bolts. Use these ones for dry valves. We want to install surface mounted panel. We want to install panel, a strut. Which type of the bolt most suitable for? So we want to install a strut in a surface mounted panel. On a surface mounted, we want to install a panel, surface mounted panel on a strut. Which kind of bolt or system we use? Lag bolt with spring nuts, self-tapping screw with washer, treated rod, and spring nut with bolt. So these are struts. We install on the wall and then install panels on them. This is the lag bolt, because it's like this, lag bolt. Spring nut. Yes, we need a spring nut for struts. For strut, we put the spring nut in the strut, but not lag bolt. This bolt, we need bolt actually, not lag bolt. We need bolt and spring nut for install panel. Treated rods. Sometimes we use treated rods when we want to make a more distance between the panel or electrode. Self-tapping screw. Because of that, because of this drill. So spring nut with bolt. Can be correct answer. Spring nut with bolt. And also we can use this one, treated rod. Electrical aluminum pole, but we use this one, self-tapping screws for install the strut. When we want to install a strut on the wall, we can use these ones, self-tapping screws. Electrical aluminum pole. You can see some questions about the installing aluminum poles and the sequence of installing the pole. Zone system. So zone system, zone 0, 1, 2 is about the gas, and 0 is continuously, 1 is likely to occur, 2 is not likely to occur, sometimes rarely occur, gas or vapor. But if it is like this, 2, 0, 2, 1, 2, 2, 2 means dust or fiber, so these are two, dust or fiber. But 0 means continuously, this 0 means continuously, this 1 means likely occur, this 2 is not likely occur sometimes. Okay, and also gas and vapor, zone 0, zone 1, zone 2, gas and vapor, zone 20, 21, 22, combustible dust. And the rush part, the dangerous part, is zone 0 or 20. Also we have group system. Group A for acetylene, group B for some different kind of gases. You can find this in appendix B. If you go and check the appendix B, you can find this table, like this table. Group C for some different kind of gases, and D and E. And in your exam, if for example, they tell you propane. For the propane, what is the group? You go to the appendix B and find the propane and find the group of the propane. Class and division. So class 1 is, this one is American standard, zone is European standard, class is American standard. So for class 1 gas and vapor, class 2 dust, or class 3 is for fiber. But we have division 1 high probability, but division 2 low probability. So also this table can help you. Class 1, you can pause the video and read it about the class 1, class 2, class 3, fiber, combustible dust, gas, and the division, most likely low likely. Okay, class A and B. This is class A because it's turned back to the fire alarm panel. This is class B because we have end of line, class B. Padlock. We use padlock for lock the system for maintenance, for example, for maintenance the panels, maintenance the motors, electrical equipment. NPN or PNP, anode or cathode. So anode is positive, cathode is negative. NPN is a negative transistor. PNP is a positive transistor. P it means cathode. Sorry, anode. This one is negative transistor and NPN. So we have cathode, anode, and cathode. So cathode is N, anode is P. Cathode, so cathode, anode, cathode. So we have two cathode and one anode, and it is negative because we have two N, both sides of the transistor. But this one is anode, cathode, anode. So we have, this is positive transistor, anode, cathode, anode, and it's emitter, collector, and base. I've seen this question. For example, they ask how many positive and how many negative the semiconductors we have in this transistor NPN. So we have two negative and one positive. Two negative. Negative is cathode, this one, N cathode negative, P anode positive. And it's about the diodes, anode and cathode. Anode positive, cathode negative. And also again transistors and how we show the diode. Single rip belt. So single rip belt, we use it, and belt pulley system, belt single pole. Deflection, if we push finger on the belt, it's go in, so we call it deflection like this, how much it go up and down, deflection. Tension force, trench, we call it trench for electrical. Elevator travel, floor access control, this is access control system, we use it, access control system. High pot testing, this is high pot testing, we test the insulation of the high voltage cables or high voltage devices, equipments. High voltage, we test high voltage with hot pot testing. And stress con, we use stress con for high voltages, for termination of high voltages cables, for protect the high voltage cables, insulation of high voltage cables. We use we use stress con. For the high voltage cables, stress con. This one is a stress con insulation material. And like this, high voltage cables and termination. Inverter vs converter vs rectifier. So rectifier AC to DC, DC to DC is DC chopper or DC converter, and inverter DC to AC. And again, AC to DC rectifier, DC to AC inverter, DC to DC converter. Solar panels, this is the system wiring of solar panel, DC combiner, wires, meter here, inverter AC disconnecting means, utility from the utility transformer, mounted transformer, and meters and service disconnecting means, how we connect them. Plenum, this space, this area is plenum. SOW cable is a heavy duty 600 volt oil resistance. So W is for oil, stand for the resistance, but W O stand for oil, W stand for wet or water. Instrument transformer, CT or PT, we use CT, current transformer, for measurement, for meter, for measure the current, high current or high voltages. Coupling capacitor, voltage transformer, step down transformer. BIX communication, punch down block, these ones for telecommunication, for usage for BIX communication. And we use this tool for terminate the wires, communication wires in the BIX communication punch down block. Suspended ceiling, this one is suspended ceiling. Power cable puller, for heavy cables, power cables, we use power cable puller. Hand, this one is working with hand, but manual, this one is working with electricity power. Forklift, this is forklift. Common line, this is common line for heavy lift. Forklift, common line, this one we use it for heavy equipment like transformer. 3-point starter DC shunt, this is DC, this is shined winding, this is series winding, this is the armature, this is the accumulators, our brush, and this is the 3-point starter with the resistors to control the speed of starting. And synchronous motor, we have DC supply for the rotor, and this is a stator we use for generators. So most of the time we use for generator or correction factor. Fusible disconnect switch, so we have disconnect switch like this, and we use fuses for connect or disconnect the load. Service box, this is service box. And so different kind of XLP, PVC cables, and table 8 how much you can, the percentage of the cable for one conduit. From one conductor we can occupy 53% of the conduit. For 2 conductors 31%, for 3 or more 40%. Other actuated tools, we use these tools, powder actuated tables, tools for the masonry or concrete fasteners. Also these ones for concrete, we use it, make it easy, working easy. Thermite welds is a kind of welding that most of the time we use it for grounding system, connect the copper conductors or rods, everything together with thermite welding. CAD welding also is like that, high temperature process, create permanent molecular bound electrical connection. We use it for, it's the best way to join, connect the grounding conductors together. Again, it's about the receptacles, different kind of electrical equipment, symbols and drawings, and that's it. Okay, it was a long live video. Thank you for watching this video. Please subscribe and like my videos, subscribe my channel and hit the like button. And I have some more videos related to this book, but this video I tried to review all the most important parts of the book in this series of the videos, because in this way you can understand which part of the book are most important parts in your exam. Okay, have a good one. Stop streaming. When start recording, stop streaming. Start streaming. Let me to check, is it working or not? Okay, let me to go here to the YouTube and okay, let me to go here to the YouTube and 305 mostly. Okay, I think it's working. Let me to stop the video, stop streaming.